So, good evening, guys. First, let me welcome all of you on behalf of Sunbeam onto the next journey. This is the journey where we are going to walk together for two certifications. One is the Docker certification, Docker Certified Associate, and the second one is a Certified Kubernetes Application Developer. So these two certificates are, you can say, one of the top certifications, one of the top certifications or certificates in upcoming years. If you go on Google and if you see the trending, then you see that the DCAs and CKADs and CKAs are always in demand. See, DevOps is almost everywhere. You might have heard about that word DevOps. You might have gone through the different requirements, and you see that many companies already have adopted the DevOps culture. If they already have adopted the DevOps culture, they need people who know all of this stuff. When I say all of this stuff, I'm talking about a couple of technologies. One of them is Docker. Second one is something like a Kubernetes. Third one is CI/CD pipeline like Jenkins. Next one is Ansible or Chef. Maybe you can say configuration management tools. Again, something like OpenShift, so that we can manage the Kubernetes nodes and other stuff. So all of these tools are in demand these days, and that's the reason why we have decided to help people to pass their certifications. Hopefully, you know the value of certificates. So these days, if you are looking for finding a new opportunity in the DevOps world, or maybe if you are looking for changing your career or switching your career or finding new horizons in this DevOps category or DevOps world, then these two standards or these two certifications are de facto standards. When I say de facto standards, companies are always looking for the certified people or certified employees. Generally, companies are also demanding their existing employees also get the certificates, and not only existing employees, they are looking for the new recruiters or recruitments to be done on the basis of certifications, and that's the reason why we have started this course. This is not the first cycle, this is not the first time, this is rather the fourth cycle. One we completed offline, and this is the third one online. So altogether, this is the fourth iteration. Now, when we talk about this iteration, now there are a few fundamental changes done from last couple of batches. Till last time, we were just spending only 2 days on Docker, 2 days on Kubernetes to get the things maybe introduced to the world. That's it. So that was a kind of introduction to Docker. That was a kind of introduction to Kubernetes. But looking at the demand, companies are also asking us to start a course for the other employers, or maybe other maybe you can say candidates, so that they can earn their certifications. And from these requirements, we started this course. This is a Docker plus Kubernetes. I mean, unfortunately, or maybe fortunately, should I say, uh, from last couple of months, when Docker has updated the certification requirements, so DCA requirements, they introduced something like a Kubernetes in the Docker certification as well. You might have seen that when you are registering for Docker, you by default get registered for Kubernetes as well. And there's a reason behind this. The simple reason is when you are going to appear for DCA, the orchestration is one of the parts inside that exam that contains both the Docker Swarm and there is something like a Kubernetes. Don't worry about the words, about the about the, you can say, yes, about the jargons I'm going to use. I'll clarify every single thing later when we are talking about all the subjects. Okay. So don't worry about the jargons. Okay. So, okay, just give me a minute, guys. Just give me a minute. Okay, sorry for the interruption in between. Yes, I got a message saying wait for a couple of minutes. People are still joining, so I had to stop abruptly for a minute. So sorry for that. Again, let's join the let's join where we left last time. So I was saying right now this is the de facto standard, and that's the reason why we have started this course. So I was talking about some fundamental changes. Till last time, we were just giving the introduction to the world, like what is a Docker, what is a Kubernetes, and what you can do with the Docker and Kubernetes. That's it. But this time, we decided to go for maybe creating a course for preparing people for their certifications. Again, this is not only what we have decided. This is what the industry already have sent so many requirements to us, saying you have to start the certification course so that people will get trained and people will go for their certifications, and those certification holders they are looking for. So that's the reason why we started this course. This is going to have, I mean, a lot of value, not only up right now, but it is going to have a lot of value later in upcoming future. Every certification has got some expiration, so depending on which technology you are going for, it's a 2 years and 3 years, depending again on which certifications you are going for. Okay, so let us start with the subject first. Let us see what exactly we are going to do, and then I'll answer a few questions on the fly. Okay, I'm constantly watching the questions you are putting there, so I'll try to answer those questions in upcoming sessions. Okay, so if I do not answer your question, don't worry, you will get the answers later. Okay, so let us start with the subject. Let us start with the course. Again, those who have just joined, let me again welcome you on behalf of Sunbeam. So we are going to start a journey towards the certification. Certifications from two different world and two very important world. One is a Docker and second one is Kubernetes. So let me introduce myself first, and then we'll start with the subject, because it's important to know whom you are going to get the training, and it's important to know like the person sitting in next to you is either capable of doing this thing, or maybe either going to help you, or whether you can trust him or not. Of course, it's very it's kind of impossible to trust someone just by looking at it from thousands of miles. So it's important to know who am I. So my name is Amit. You know that. There's nothing to be talked about that. So I'm having a decades of experience. I've worked in various different domains. Maybe you can say that I'm a freelancer by default, as a mobile developer, as a website developer, and as a platform developer. So I develop a lot of applications. I have my own clients, so clients from different part of the world, and I develop the real applications for them. So I'm by profession, I'm both. I'm a associate technical director at Sunbeam. At the same time, I'm a freelance developer as well. In the morning time, I go for general the trainings. In Saturday, Sunday, in the evening time, I generally go for the training. And after 2 o'clock till 11 or 12 in the night, I generally work as a freelancer developer. So freelancing is what it gives me the confidence on the technologies, because when we are developing real-time applications or real-life applications, you will see those problems which other people are going to see, and you can help the people to solve those problems. So it's like I'm putting my I'm putting my foot on both the stones, training as well as development. So whatever I learn there in development, whatever experience I get here, I go for the training. And because I want to go for a training, I have to train myself continuously. I have to learn continuously. So it gives me both confidence while training, and maybe helping the development world to contribute with the new things that I'm learning for delivering the sessions. So it's like the benefit from both the world. I've worked in various domains, as I say, with the very different technologies. Mainly, I started my freelancing career with iOS and Android development way back in 2008. Till now, I stopped counting, but there are more than 180 applications I developed for iOS, Androids, Windows phones, Blackberries, and others, and numerous websites. When I develop website, I generally use the PHP. That's a means. Sorry, that's the MAMP or LAMP or WAMP stack, whatever you can call it as, depending on the operating system you are using. I prefer Linux, so I use LAMP stack there. Recently, I mean, starting from last couple of years, precisely starting from 2014, 2015, started developing the mean and the moon applications as well, where A stands for Angular and R stands for React. You might have seen this in upcoming or maybe in Boom these days. So I developed the applications from both the sides. Now, why we have started this course and why we are talking about preparing you for the certifications, because I myself hold all of the certification. So I myself am certified Kubernetes application developer. So this is the certification we are going to start in next 2 weeks. The certified Jenkins engineer, this is the certification for CI/CD pipeline. This is the Jenkins part. And another one, the one which we are studying today, is this Docker certified associate. So this is, again, I'm having all those certifications under my belt. So I know what kind of questions I faced during my exams. So I can give you some tips and tricks, and then probably you'll be able to hopefully complete your certifications. So that's the reason why we have started this course in the first place. Okay. So trust me, whenever I say that this is important, you have to pay a little bit closer attention. And probably when we are doing this stuff, you have to literally do it by hand. Let me remind you, and it's very important. When you talk about this exam, Docker Certified Associate exam, now this exam is question answer based exam. In a sense, you literally will sit for 90 minutes and you will answer the questions like 55 or 60 depending on the topics and depending on I mean it's a random actually. So when we are answering those questions, very important, these are multiple choice questions, but you know what, these guys have made your life so difficult that even though it is multiple choice, the question will appear first, then the answer. And if you say this is the correct answer, the next answers will never come. If you skip that answer, thinking about let me see a couple of other answers and then let me decide which one is the better option and then I'll choose this, you will have no option like that. So there are few questions, almost like 14 to 19. Again, it's completely random, but 14 to 19 questions will be following this pattern. It's very difficult when we are answering this kind of questions. So you see a question, you see an answer. If you see the answer, if you say okay, you never will get the next answers there. And if you wait for the right answer, you are losing your chance. So you have to get the confidence on the technology and you have to get the confidence while answering your questions. That's the DC. When we go for certified Kubernetes application developer or CKAD exam, now this is not a question answer based exam. This is where you are going to sit next to your machine. There will be a virtual machine created for you and you will log in into that virtual machine and they will give you almost like 25 19 to 25 questions in the sense the maybe the problem statements, and you have to solve those problem statements by literally putting the commands inside the shell. So this is literally a practical oriented exam. I like these kind of exams because I don't believe in the question answers, because people generally do the brain dumping and they generally start giving this exam. That's the reason DCA has made it very difficult. Not like the other exam where you just by heart the question and answers and you go and appear for the exam and you get a certification. It's not like that. Certifications are very tough, and that's the reason why these certifications carry value. You know, so if you go to industry and if you tell you are certified Kubernetes application developer or you are a CJE or a DCA, people know that these certifications are really tough. And if you are passing those certifications, that means you have the real knowledge about that technology, and that's the reason why I'm saying this is going to carry a lot of value. That is going to add a lot of value into your resume as well if you put these icons into your resume. Anyways, I generally go for certifications for my own satisfaction. So this is a kind of a story behind the entire course here. So remember, this is a practical oriented, and this is where you are going to find difficult questions. Believe me, those are difficult questions. Anyways, we'll walk together and we'll see. If you face any problem, I'll be always there with you. And of course, we are going to do these things practically. Very important, whatever we do here, you have to do that practically on your machine and get the things working on your machine, and you have to get the confidence by doing the practice. All of the certifications require lot of practice, and when I say practice, lot of practice, believe me, you will see that. Anyways, enough about myself. Let me introduce you to the course here now. Now, when we are going for DCA, now this is not what I am telling you. This is something which is coming from the official study guide given by Docker for this exam. This exam is where we are going to go for DCA, certified Docker certified associate, where we are going to have 6 domains, and those domains are kind of they will carry the importance, and those domains will be a part of this course. So this course is based on all of these 6 domains. The very first domain is the installation and configuration. Next one is the image management, the networking, the security, storage and volumes, and the orchestration. And this is where, you know, though you are going for Docker certified associate exam, there will be questions on Kubernetes. So this is the reason why we are asking you guys that if you are participating for DCA, you have to continue to the Kubernetes, because partially, excuse me, the sixth one is going to be common for CKD and the DCA. That's where the Kubernetes is needed. Okay. uh, what okay, by the way, when we talk about the Kubernetes, there is one more certification here, that is something called as a CKA. I'm preparing myself for that. Didn't get time because I'm having a very busy schedule, developing the applications for other clients and delivering the sessions in the morning, so I find very little time to prepare myself. So still I am, preparing for this CKA, and when I find time, I definitely will go for the exam. So what's the difference here? Because when you go for certification for Kubernetes, you will find option number 1 and option number 2. We are going to cover this we are going to cover this from end to end, and we are going to cover few topics of CKA as well. What's the main difference? This is for application developers. I mean, those who are developing applications, they want to move their applications or containerize the applications into Kubernetes. This is the certifications for them. This is for a developer. While this is certified Kubernetes administrator, this is for ops person, how to manage the cluster, how to configure the cluster, how to debug the issues in the cluster, how to make sure that your cluster is up and running, how to backup and maybe restore the cluster data, how to upgrade the clusters, and so on and so forth. Administration related tasks will be covered here. And there are a few topics I'm going to cover inside the sessions, though they are not part of CKAD, but I know those are important when you are going to install your own clusters on your machine. So we are going to see a couple of different topics from the CKA as well. And besides, I'm preparing for that exam, so I always know what exactly is going to be there. So we are going to cover these things there. When you are going to study for CKAD, you almost are 60% prepared for CKA as well. 40% syllabus is a little bit different from the CKAD. So 60% you already are prepared for CKA, those who are willing to go for the other options as well. Okay, so I was talking about all of this here. And when you say Kubernetes, Kubernetes has got 2 certifications there. Anyways, let us see the requirement again from the different domains. And this is something that we are going to see in this particular sessions for DCA. Okay, this is for installation and configuration. Now here we will see how to install Docker on 3 different operating systems, on Windows, on Linux, and on Mac. Though Windows and Mac, they are not needed for your so-called exam. On exam, what you need to see, or what you need to answer the questions only from the Linux point of view. Why? We'll mention that later. But this is something where we are going to install this. Not only that, the installation is going to be in 2 different parts. One will be Docker CE. I'll explain every single thing. Docker CE and Docker EE. Both of them are important. And all of these topics you see here, UCP, DTR on AWS, and all of that stuff, that will come in the almost in the last part of our sessions, where we'll talk about how to install the Docker EE Enterprise Edition on your machine or on the AWS, how to configure the UCP control plane, or how to use the DTR trusted registry, Docker trusted registry on AWS, and stuff like that. So we'll see all of them there in the sessions, in the upcoming sessions. Now, when you talk about the Docker, the core part or the heart of the Docker is container. But to create a container, we have to use something called as an image. We'll see what is an image later, but this is what we are going to see maybe starting from today and tomorrow. So we're going to talk a lot about what are the images, how to create the images, how to upload the images to the registries, and so on and so forth. So this contains, see this, installation is going to have 15%, and the image creation and management and registry is going to be 20% of your exam. That covers how to add, how to copy volume, how to add the entry point, how to expose the part, how to create the images using Docker file, how to create or how to manage the images, how to list the images, delete the images, prune the images, remove the images, and so on and so forth. A lot of things in the image creation stuff we are going to see today and tomorrow. Now, once you know what images are and how to create all of those images, we have to start talking about the containers, and those containers, they will connect to each other where the networking is needed. Very important that when we are going for not only Docker, but also in the non-Dockerized environment, when we are having multiple machines, we want to share some data between the machines, and that is needed when, I mean, if you want to do that, this is needed. That is, networking is needed. So we'll see how to enable networking so that multiple containers can talk to each other. There are different types of networking. We'll see that is a bridge network, ingress, host network, and there are MCIs, and there are a couple of other type of networks we will see. Again, important part, 15% of your exam. So networking will allow multiple containers to talk to each other. So we'll see what are different things are needed, and we will configure them right here. So it is again one of the topics of your, I mean, the DCA exam. All of these are the domains. This is the networking domain. The next one is the security. I mean, I don't need to tell you how important that topic is. This is 15% of your exam, but this is the most important part, not only from Docker, but also in the other application development as well. Security. These days, internet is everywhere. I mean, it's there with you, it's there with the hackers as well. As you are sending the data from one container to another container, data will be captured by, for example, hacker. So how do you secure your data? How do you secure your images? How do you see that the images you are using are already given or already signed by trusted certificates and all of that stuff? There is a RBAC, role-based role-based access control. Maybe you can configure it with the LDAP or Active Directory, or you can use the MTLS. That's a protocol which is going to make sure that you are using the transport layer security there, and so on and so forth. The next one is going to give you a kind of option to store your data permanently. I mean, containers are not made for storing the data. Containers are made for stand alone, and they are not supposed to store the data inside them. They are supposed to store the data outside, and this is where the storage and volumes will come. So again, important part where we are going to see how containers can store the data outside the containers itself by using something called as the volumes. Again, the same topic will be there in CKAD as well, but from the Kubernetes point of view. We'll see there, storage and storage volumes. So here we are going to use the storage options and the volume options. Precisely, there are two, and we will see them in the next sessions. Not tomorrow, in the next weekend. That's a storage and a volume. Again, 10% of exam. Not that big, but yeah, this carries a lot of importance because unless you persist your information, the data will be lost. So you have to store the data somewhere. By using storage and volumes, we will persist the data. And finally, this is the orchestration. This is the most important part of your exam. And this orchestration now contains both. This is called as a Docker Swarm, which was there as an only solution from the Docker. But these days, Docker is also preferring to use something like a Kubernetes. And that's a reason why Kubernetes is already added in the exam. Inside this, you will not see any of the things related to Kubernetes, but in the exam, you will see a lot of questions on Kubernetes. And this is the reason why we are going to look for both Docker Swarm as well as Kubernetes when we talk about the orchestration. This is the most important part for you as kind of administrators, you know. So associate means you are kind of an administrator plus developer. So you are beginning your career there as both administrator as well as a kind of excuse me, as a developer. So you as, I mean, developer, you will have to integrate your applications or get the applications and put them inside the container. And you as an administrator have to create the cluster, have to move your applications to the to the environment or to the Docker Swarm or to the Kubernetes and manage them. So that is what you're going to do as a developer and an administrator when we are talking about this requirement here, DCA and CKA. So when we are talking about this entire DCA part, these are the 6 domains. I hope you must have gotten an idea here: installation, configuration, image management, networking, security, storage volumes, and orchestrations. So that will carry, I mean, that will comprise to 100%. So this is the syllabus, or this is a kind of, you know, the contents we are going to see in the next couple of days or next 2 weeks, only for the DCA part. For CKD, I'll tell you, the topics are different and the contents will be completely different than what we are going to see here. We definitely will see how to configure all of this towards the end of it on AWS, not on Google Cloud. So probably we'll see that there. And for example, I'm going to use a very simple HTML example for it. If you want, you can use any of the applications you are familiar with, any of the technologies you are familiar with. If you want to use something like a Spring Boot, or if you want to go for mean application, you are always welcome to do that. I'll give you a couple of examples, like how to create a complete solution for a mean application because I use it. Then I'll give you how to use the application or how to create the containers and how to store the data in the database side, because without that you can't complete your application, so that is needed. And lastly, how to make your website hosted inside the containers and how to make the containers appear inside the Kubernetes world. So that's what we are going to see there. So I think those who are asking that question, they must have gotten the idea here. And once we know one application, you can definitely look at the other applications or the applications which or the technologies which you are working with. So not a big deal. It's very simple, and probably if you know one stack, you can automatically go for the other stack as well. Okay, so now we know like what exactly we have to cover. So let us go back and see how we can start preparing for ourselves. Okay. So to start with this, we will go with the first thing, and that is very much needed, and that is something like a fundamentals. Because unless we know the fundamentals, unless we know where we are going to start marching towards, we'll not understand what is the actual requirement and why we are even looking at that part from different eyes. Okay, so let us understand some fundamentals things. Even if you know this, it's okay. It will be kind of a revision for you. Probably just go through it quickly, and then we'll start with the actual part of Docker. So when we talk about the Docker is a solution for containerizing application. But what is a containerizing? Containerization is the way you are going to deploy your application in such a way that the application will be available all the time. So is that the standard practice these days? Yes. Was it the standard practice earlier? No. Earlier, when people were not knowing something called as virtualization, they were using the real machine. So think about the scenario. If a company wants to, let's say, put their website live for the other users. I'm talking about, let's say, scenario of 1990s, for example. There's a company, for example, we are in the 1990s right now, and there's a company who wants to, host their website for different users. How would they do that? So in that part of the world, they were supposed to get a physical machine. See the requirement. They were supposed to get the physical machine. This is the physical machine. We are talking about the hardware part of it. Then, of course, hardware is just a physical components. They cannot work on their own. So we'll have to install operating system on top of it. Then you install the required binaries, libraries, platform, runtimes, all of that stuff. And then you will copy your applications. For example, when I say this is going to be a kind of, the Java application, then I will install JVM. Or if it is a Python application, I will install, let's say, Python runtime. Or if it is, let's say, something like a .NET application, then I will install the .NET CLR, for example. So all of that stuff is nothing but that binaries, libraries, or platform we have to install on top of operating system. And there we will run our application 1, 2, 3, and 4, whatever, for example. Now, the problem with this strategy is when people were getting that hardware, they were not knowing like what is the right configuration to run an application there. The scenario was like this. So maybe this is the machine, and inside this machine, of course, there is a hardware, of course, there is an operating system, and let's say there is an application here. Now, this application, because that was the era when the people were trying out the things, they were not having the exact requirement. So probably, let's say this is the server machine, and an administrator in the company would go for something like a requirement of, let's say 8 cores machine plus, let's say, 64 GB of RAM. Oh, 64 GB is too much at that time. So maybe I can say 16 GB of RAM. And on top of that, you are going to put your application. So this is the application I'm going to add on that server machine. Now think about this. What if this application requires the full resources? Then probably you are utilizing your resources. Fine, I'm happy with it. But maybe if the application is not, utilizing those resources, that means the application is kind of underutilizing resources. You are unnecessary wasting your money into it. Probably you could have gone for 4 core or 8 GB of RAM, and then the application would have worked. But because the administrators were not getting the clear-cut idea. They were facing these issues. Another big problem with this strategy was this. Probably if the application is underutilizing, for example, and that's the reason why administrator decides to go for another application hosting on the same machine. And because of the second application, if this application is eating almost like, let's say, 7 GB of RAM because of some bug or because of some requirement, this application was kind of underperforming. So this application is underperforming because it's not getting enough resources to run. And that is the main challenge at that time people were facing when they were going with something like the physical servers, or they were using the actual machines, the physical machines there. So how did they solve the problem? They solved the problem by running multiple applications on the same machine in multiple different compartments called as virtual machines. And that's the need of virtualized deployment or virtualization in the first place. Imagine you are developing a Java application and you want to see if the Java application is running well on your Windows platform, Linux operating system or Linux platform, and in the Mac platform, because Java is kind of platform independent. Before I send my application to my client, I want to make sure that it is working well on all the three platforms there. So how do I test it? If I want to test it, then probably I can go for three different machines. Could be something like this. I'm going to have one machines where I can install Linux. I have another machine, for example, I can install Windows, and I'll have to pay almost like a couple of lakhs. And then here I'm going to put Mac, and then I will run my Java application there, and then I will see whether it is working fine. That is strategy number one, where we have to go for three different machines. Maybe in the second version, you can go for only one large machine and you can install all of these operating system, Windows, Linux, and Mac on one single machine, for example, like this. And then you will, boot into one of them, and then you can test your application. This is where we can go for multi-booting. Both of them are having their own pros and cons. This is maybe a kind of advantage that you can run your application simultaneously, or you can test your application simultaneously on three different platforms. But what is the downside of it? It's because it's going to be too costly to have three different machines with three different operating systems. People generally not tend to put that much of money when they want to test the application. So that is downside of this strategy. What is an advantage of this strategy? Again, you are going to lower down your budget. So you are going to use only one machine where we are going to install three operating systems. So definitely budget wise, it's a good solution. But what about the otherwise? You cannot run all of these operating systems at once because all of them are installed on the same machine. When you want to run Linux, you will have to boot into Linux. When you want to run Windows, you have to boot into Windows, and same goes for Mac. So both of them were having their own pros and cons. And that's where people started thinking about virtualized deployment. Now, what happens in the virtualization? See here. In the virtualization, this is where my physical machine will come into picture. This is the hardware. This is nothing but my physical machine. On top of that physical machine, to use those hardware components, we install the operating system, whichever operating system you go. For example, this operating system can be Linux or something like a Mac, let's say Mac OS, for example, or this could be something like a Windows, so it can be any one of them. This is your physical application, physical machines operating systems. Sometimes this is known as the host operating system. And on top of that host, you install one of the hypervisors. Hypervisor is the application which is going to enable you to run virtualize the environment or to run virtual machines on top of it. For example, when you go for hypervisor, there are two types of hypervisors available. One is called as the type 1 and the second one is called as the type 2. Now I can bet on that type 2 is something you already must have heard about. For example, tell me, have you heard about something called as a VMware? Or have you heard about something called as VirtualBox or VBox, which is a free and open source? Excuse me. You must have, right? So both of them are considered as a type 2 because they have to have the operating systems on that machine. Because if you want to use VMware, you have to have a first host operating system. On top of that, you will install VMware. In the type 1, I bet you might not have heard about them, but they are very popular for the cloud providers. There is something called as the Zen, and there is something called as not the one which I mentioned earlier. There is a special version of VMware called as VMware ESXi. This is used as an operating system itself. So this solution does not require operating system on your hardware because the type 1 virtualized environment or virtualization application itself will act as an operating system. While type 2 will require you to have an operating system. That's the difference between type 1 and type 2 virtualizations. You install the virtualization layer, you install the hypervisor on your machine, and on top of that, you will create the required virtual machines. Earlier, we were using the physical machines. So you go anywhere when you want to run your application, you have to have one, the application itself, I mean the code of that application, or maybe you can say the application files. And second, the binary or runtime to run that application. So that is needed. If you are going for physical machine, you will put that on physical machine. If you want to run that inside a virtual machine, so you will go for your physical machine operating system hypervisor, and within hypervisor, you will just create one more virtual machine like this. So virtual machine itself is a machine, not the physical one, but the virtual one. But because it is a machine, it is going to have its own operating system. Let's imagine the fact that I'm on Mac right now, but I want to show you how to install Docker on both the operating systems. So I'm already logged in here on my Ubuntu machine. So this is my Ubuntu machine. I'm running I'm running the Ubuntu on top of Mac using virtualized environment. This is in VMware. And there is another one, Windows. So this is the Windows. I'll show you how to install this thing here, how to install the things here, and how to install the things on Mac. So I'm using Mac as my operating system on my physical machine. I'm using a physical machine as an iMac Pro here. And on top of it, I've installed, this is my host operating system, Mac. On top of that, I've installed the VMware. And on top of that, I'm running virtual machines, two virtual machines, Ubuntu and Windows, which is having its own operating system called as the guest operating system, here. So Mac is my host, Ubuntu here is the guest, Windows here is the guest. So that's how it goes. On top of that, you are going to install the binaries and runtime. For example, if I want to test a Java application, I will install the Linux and Windows there on top of this, and then I will install Java there. And on top of that, I will run my applications there. So that's one of the ways we are going to make our application available for end users. This is the traditional deployment I talked about last time. This is before the virtualization, pre-virtualization. In the virtualization, you are having the physical machine, and on top of that, you are running few virtual machines. The benefit is because it's a virtual machine, these applications will not have any kind of dependency. The application here will not affect the application running here. That's the main advantage of running applications into virtual machines. Whereas if you look at the previous scenario, because this application is getting all the resources, this application was underperforming. Now that is not going to happen when we are talking about the virtualization here. That's the reason why virtualization is better than the traditional deployment. But you know what? When we are talking about that virtualization, or when we're talking about that virtualized environment, though it is a good start, this cannot be the final solution, or this should not be the final solution because of one basic problem. I'll show you the basic problem. You see that yourself. I'm going to go back here, and probably will. I'm sorry. Can I? I can. Yes, I'm going to go back and shut down this machine for a second. And you will see that this is the real operating system. So if I'm shutting down this machine, and let's say I want to restart that machine, what is going to happen? Now, because this machine is going to get restarted, this is the real operating system. You know what? This is the real Ubuntu operating system. That means it will start booting. Because it is going to start booting, it is going to take time. That's the main problem when we go for virtualized environment. This requires full booting. And when I say it is a booting, it's the real operating system. It has got ton of other things. I mean, because it's a real operating system, you see, it is going to have the G-Edit, it is going to have the GUI and whatnot. I mean, whatever you are having on your machine, if you're installing your Ubuntu, it is going to have every single thing there. The problem here is when we are kind of looking at this requirement, I'm creating this virtual machine not because I want to use the operating system. I'm creating this virtual machine because I want to run the application there. That's the main reason why we are creating this application, why we are creating these virtual machines. So this is the culprit. This is the main problem, the operating system. And that's the reason people were looking for a better solution. And that better solution is given by containerized deployment. So this is where the container is needed. Shailendra, you don't have to record the sessions. The recording already has been enabled. I'm recording the sessions and I'll make this available for every one of you. So don't worry about that. Okay. Shailendra, you will receive the recording later, maybe later tomorrow. Don't worry. So coming back here, this is where the containerized deployment will be needed. So what is the, I'm sorry, here it is. What is the main drawback of it? The main drawback of the virtualized environment is like when we are talking about virtualization, it is going to need a kind of a full operating system, and that is the main problem. So this is the main problem. See, this is my physical machine. On that physical machine, I'm having the hardware, I'm having the base, or you can say the host operating system. On top of that, there is the virtualization layer, or you can say hypervisor. Hypervisor is the better word here when we talk about the virtualization. On top of that hypervisor, we are going to create a virtual machine. And this virtual machine, let me just bring it, a kind of zoom it here and show you what exactly is the content within it, because that is what we are going to compare with the containers here. So this is the virtual machine. Let me mention that this is a virtual machine. This virtual machine will have its own hardware layer, the hardware layer for virtualization. So this is going to be virtual hardware layer. There, all the hardware components, physical hardware components will get virtualized by using this hypervisor here. That's where the hypervisor is needed. The hypervisor is going to make all the physical hardware as virtualize the hardware. On top of that, because it's a hardware, on top of that, we are going to need an operating system. I'm just going to make it idiot. So I'm going to make it a little bit bigger. So this is a kind of operating system layer where we are going to have everything inside the operating system, because it's a real operating system. So it is going to have all the GUI, it is going to have the networking, it is going to have ton of utilities, though my application is not going to need it. For example, look at this. This is the full Windows. It is going to have everything there. It's going to have that worst browser Edge, for example. It's going to have all of these things there, and that's a reason why it is going to make your life so slow. On top of it, you are going to install the binaries, or you can say the runtimes or environment. So I'll call it as a runtime, or I'll call it as a platform. For example, Node, for example, JVM, for example, CLR. And on top of that, you are going to run your application 1 or your application 2, and so on and so forth. That is how the virtual machine will come into picture, and that's how the operating system is going to, that is how the virtual machine is going to work. This is the full operating system, so it requires booting, and that is the main problem of this application. See the scenario. Now, this is something which you need to know. So probably think about the real life requirement. This is my server, for example. This is a client here sitting somewhere in India, for example, and probably want to view a website which is hosted on this server. There is a network in between. So see the requirement and see the problem and see the solution. So when I say this client sends a request, maybe this request goes to that server, and the server gets the request, processes it, and then sends a response back to the client. Let's assume that there is only one client sending, let's say, 10 requests. Maybe this is the server which is having, let's say, a CPU, the memory, and the other components, the hardware components here. I'm going to say mem, and the rest of the other components there. This CPU can hold or can run, let's say, 10 or let's say 20 threads, for example. So what happens here is, when a request is sent to the server is going to create one thread per request. Meaning, if this client is sending 10 requests, and if there is another client sending 10 requests at the same time, this server can execute all of these requests simultaneously. But for example, your website is getting popular and maybe another group joins, or another set of users, another, let's say 10 users started using your application, your server will get too many requests at the same time. The server is capable of handling only 20 requests, but at the time it is getting 30. So what is going to happen? The server will say, hey, I can handle only 20. Those 10, you go and wait till I finish the existing 10, and then I'll give you a chance, and then I'll execute your request. So those 10 will go in a wait set. Have you seen this kind of behavior earlier while booking train tickets, for example, in IRCTC? Sometimes, the website goes, sometimes it goes down, sometimes it becomes so pathetically slow. You can't do anything there. It's just because of this problem. This is called as the scaling problem. Very important part, scaling problem. Now, how do you solve this problem? I mean, the things will go even worse when your application is so popular, and let's say there are 1,000 requests coming, and your application will go down. So your server will not handle that much of load, and yes, your server will go down. So how will you handle this problem? To handle this problem, we have got two scenarios here. One scenario is called as a vertical scaling. Let me just say that this is going to be a vertical scaling. So what do you mean by vertical scaling? The vertical scaling means the server which we were using earlier, maybe this was the server I was using earlier, which was only using one CPU, for example, which was having, let's say, 32 GB RAM, for example. What will I do? I will increase the configuration of this machine and will say that, hey, now I'll make it a little bit bigger. When I say it is a little bit bigger, it will handle many requests than it was handling before. So that is how I will handle multiple requests coming from different clients simultaneously. So now we can handle multiple requests there. So all of them are sending the different requests to our server. Earlier it was handling, let's say 30. Now let's say I add one more CPU. So not one, let's say I add, say, 8 cores, or not cores, sorry, 8 physical CPUs, and I increase the capacity by 8 times, for example. So let's say it was handling, say 20 requests earlier. Now 20 into 8, now it is going to handle 160 requests, for example, I'm saying. So now see, vertical scaling means we are upgrading or downgrading our server configuration as needed, and then we will handle the scenario. This is the solution called as a vertical scaling, but it has got a big problem. The problem is, what if the server goes down? What will happen? No client will get the response because the server is down. And that's the main problem of using the vertical scaling issue. That's the reason why we are not using or not following only vertical scaling here. Why we generally go for something called as a horizontal scaling. This is called as the horizontal scaling, and that is the main reason why we are going to use the containers. Watch this. This is where we were using the server last time. In that server, we were having all the applications and everything there. And this way, this was client sending, let's say, 10 requests. This client was sending 10 requests, or maybe this client was sending 10 requests. Of course, there is a network in between, and now all of them were sending the request like this. So when we are thinking about finding the better solution here is not to increase the CPU or not to increase the configuration of the machine, because even though you are increasing it, earlier it was pretty much small and it was handling only 20 threads, but because I've increased the hardware, then it is now handling multiple requests. So that is one way to solve the problem, but again, this is not foolproof. So what is the better solution? The better solution is go for horizontal scaling. And when I say horizontal scaling, that means create clone of these machines. This is my first machine. Probably I'll go for the second machine. Probably I'll go for the third machine, and so on and so forth. So now, instead of depending on one single machine, I'll create the clone of them. When I say clone, I'm going to literally copy them, and I'll literally run my applications not once, not twice, but 6 times, for example. So I'm kind of, multiplying 6 times the requirement I was having earlier. So if I could handle, let's say, 20 requests per I mean, simultaneously, now I'm having 6 machines. So 6 into 20, almost these many times, I'm going to handle the request. See, my capacity is now increased. And when I say my capacity is increased, it is only because of copying the applications or copying the servers at runtime. This is called as a cluster, and cluster is nothing but collection of different machines. So when we are doing all of these jobs, we are going to put one more, something called as a load balancer in between, so that we can balance the load and then we can save our application from crashing. So what the solution here, I mean, what is the better solution here? Vertical or horizontal? The better solution is always horizontal, simply because if one of the servers is crashing, we don't have to worry about that. There are 5 more servers. So if the new request is coming, this request will be sent not to the one which is already gone. Maybe it will be sent to the another one, or it will be sent to the another one. It will be sent to the another one, whichever is free at that time. Excuse me, will handle this request. And that is the main reason why in the world we are looking for going with this kind of story or this kind of scaling problem. So this is the solution that we want to go for. Now imagine you are using the virtual machine or virtualized deployment. What is going to happen? Imagine that these servers are nothing but the virtual machine. So this is my virtual machine one. If I want to clone it, it is going to create another one. If I want to clone it, it's going to create another one. It's going to create another one. Because these are the clones of virtual machines, they will need some time to boot. So imagine we are getting 10,000 requests simultaneously and your machine is still booting. I mean, after some time it will work, no doubt in that. But because the requests are coming right now, I have to find a better solution than that. The main problem is to find out a better solution for performance, for speed. And that's where the horizontal scaling generally will be, I mean, it's not only the virtualized machine, but generally will be carried with the help of something called as the containers. So let us see why containers are important and why people are running after the containers. I mean, we saw that there was vertical solution, vertical scaling, but we generally don't use this alone. We use the horizontal scaling a lot when it comes to make your application available, highly available to be precise. And that's where we want to use the containers and not the virtual machines. What is a container? I haven't defined it yet, but I'm just telling you that if I want to create a clone of it, I want to copy and paste it, it requires some time to boot. And because it is going to need some time to boot, you might lose some requests. So what is the solution? The solution is to go with the containerized deployment. What do you mean by containerized deployment? Now see what is the containerized deployment. Whatever we have seen right now, that is a kind of prerequisite, and that is something that everyone should know what happens in the real world. This is where we will start with the actual subject, the containers, the actual subject, Docker. This is the first point of it. What is the container? Understand this now. I'll go a little bit slowly from here because this is completely new. Whatever I just talked about, that is something as a prerequisite. Not everyone knows it. That's the reason I kind of quickly gone through it. But now we'll go a little bit slowly and we'll see what is the container, where it is coming from, how the containers are better than virtual machines, and so on and so forth. So what are the containers? We'll see that in a second. Before that, let us go with the actual requirement again. This is my physical machine, which is going to have the hardware. On top of that, there will be an operating system, whichever operating system you want to go for, because containers or container runtime is supported by almost all the operating systems these days. On top of that, the hypervisor layer is replaced with something called as the container runtime. Container runtime is a runtime or is an application which is going to give you a chance to run the containers on top of the operating systems. Like the hypervisor was giving me a chance to run virtual machines on operating system, container runtime will give me a chance to run containers on that operating system. But what is a container? Let's see now. The container runtime will create something called as the container. So what is a container? The container will require, or container will have, understand this and try to compare it with virtual machine. You will see immediately what's the big difference there. So, excuse me, container is the one which is going to have the application, your application source code or applications executable, whatever the application format you are running inside it, all the required binaries and libraries, or you can say the platform runtime, whatever it is, and that's it. That's it. One more time, what is a container? A container is the one where you are going to have the application source code and all the libraries or binaries required to run that application. In a sense, for example, let's say I have created a Java application. Let's say this is going to be hello.class. I'm taking a Java application because I know hopefully everyone knows Java, not from the platform, or not from the I mean, you're not a hardcore Java developer, but at least you must have heard about this. So this is a file which I want to execute, hello.class. Now this hello.class will require you to have a JVM installed on your machine. So this is going to be the JVM, or maybe I'll use a different color and say this is going to be the JVM. So unless the JVM is installed on your machine, you will not be able to run that class. So this is what the requirement is. If I'm running this on my physical machine, I'm going to run this on top of my operating system here. If I'm running it on my virtual machine, I still will need an operating system here. But the beauty of container is now this layer is gone. This layer is gone. What is left? What is left with you is only the application source code or the application's binary files and the libraries or platform you will need to run your application. That's it. That's it. So this, what you see here on screen, is called as a container. What was the main drawback of virtual machine? The virtual machine was having all of this stuff, that was also having the hello.class, no doubt in that. That was having hello.class, that was having JVM on top of, below it, and that was having one additional layer. Should I make it a little bit bigger? Of course, because that is the main problem of virtual machine, that was having an operating system. And because of operating system, it was a little bit slower. Because of operating system, it was little bit unpredictable. Because of operating system, it was unnecessary blotted with so many applications which your application doesn't even need. For example, this operating system, let's say the Ubuntu which I showed you here, it's a real Ubuntu. It is going to have the clock application, it is going to have the calendar application, it is going to have the calculator application and whatnot. If this is a Windows, then there are so many things in the Windows, and you will see everything is there inside that operating system. So if everything is there inside that operating system, my application doesn't need that. My application just need only one thing, and that is JVM. So operating system here is not needed. That's the main problem of a virtual machine. And that problem has been solved by containers. So what is a container here? A container is the one which is going to have only the application source code and the binaries and libraries to run that application, no operating system. But without operating system, how will it work? Because to make something work, we have to have an operating system beneath, isn't it? Of course, yes. But the beauty of using the containers, when we are running multiple containers on this machine, all of them will share the operating system which is installed on your machine. That is the beauty of it. So all of these will share the physical operating systems. And that's the main reason why containers are way faster than the virtual machines. And you will see that when we go to the practical part of it. So containers will take few seconds or sometimes fraction of seconds to start. Whereas when we talk about the virtual machines will take few minutes sometimes to boot, depending again on which operating system you are using. It requires booting. Containers do not require booting because they do not have the operating system layer in between. And that's the major win solution for the industry. Okay, so imagine that you want to go for cloning those servers. There are 10,000 requests coming and you want to create, let's say, a couple of containers or a couple of servers right now. Imagine if you are doing this using virtual machine, you will need a few minutes for those virtual machine to boot. Now, because those are containers, for example, those containers will get cloned within few seconds, and those 100 or 1,000 requests will be handled immediately. And that's the reason why it is going to be better solution than the virtual machine. Naturally, when Pratik, that's right, in fact, virtual machines, because it is going to have an operating system within, it is going to take even larger space as well, because it's the full operating system, though you need or not need that or not, but still it is going to be there. And because it is going to be there, it's going to eat your entire space, which is not needed to run your application, but still it will be there. And that's the reason why containers are the better options, why containers are the standard options, and why industry is looking for containerized application. And where, I mean, when they want to go for the containerized applications, there they will need you people, in the sense those DCA people or those Kubernetes people, so that they can make their application containerized, so that they can run their applications in the containers, and they can orchestrate those containers. That's the main reason. Excuse me. That's the main reason behind going to that container. I hope you must have got a complete picture now by looking at the containers and virtual machines side by side, right? So you now know what's the difference between them. I'll go through those differences one more time, but still, this is a kind of a big picture or a big difference between the container and the virtual machine. So being said that, let me now define what is a container. So probably you must have got a complete picture here that a container is going to have an application and binaries or libraries. That's it. There is no operating system, because all the containers running on that machine will share the operating system installed on your machine. See, ultimately what we need to run an application, we need only the binaries or libraries and the operating system's kernel. Kernel is the one which is going to make every single thing possible for us. So we don't need the calculator, we don't need the calendar, we don't need something else in the application. We just need the kernel of that operating system. And that's what the one which containers will be sharing with your physical machines. And that's the reason why it is going to be faster. We'll see that. So how do we do that? So let us define what a container now. So container allows developer to create and deploy the applications faster and more securely. Now, when I say faster, this is really fast. I mean, you will see that in a minute when we start with the demo, and you will see how fast it is to start a container. Sometimes it takes fraction of seconds to start, because the operating system layer is completely missing. And because operating system layer is completely missing, you can understand that it is not going to need the time to boot. And that's the reason why it is fast. A container is a standard unit which provides a single point of service. When I say single point of service, it is the one which has every single thing, the application as well as the binaries or the libraries. Everything will be given in one single unit, one single point of service. It involves the encapsulating or packaging of the software source code and all of its dependencies so that it can run uniformly and consistently on any infrastructure. When I say any infrastructure, look at this. If I use that container runtime, the container runtime for us is nothing but the Docker. The one which is going to provide the support of creating the containers and running the containers is the container runtime. So that container runtime, like Docker, can be installed on any operating system, can be installed on Linux, or can be installed on Windows, or can be installed on even Mac. And that's the beauty of using the containerized solution here. So that's how it is going to do the job, meaning it's going to run that as a one single unit, no matter which operating system you are using there. And of course, it is operating system virtualization, not the hardware virtualization. In case of virtual machine, you are virtualizing the hardware. And that's why I said here, if you look at the hardware, if you look at, where did I create that? If you look at this, it is going to use virtual hardware, maybe, let's say virtual hardware layer. So virtual hardware layer is the one which is going to be given by your by that hypervisor there. So because of the hypervisor, entire physical hardware component set will get virtualized here. I hope you might have seen that earlier, maybe on your own, but if not, then I can not create, but I can show you that right here. So when I look at maybe when I look at the settings of the CentOS, for example, I can allocate whatever number of processors I can allocate. Now this is the 14 core processor, so I get 28 cores on this machine. So this is the iMac Pro version. So don't worry about that. It has got 64 GB of RAM. So I can allocate as much RAM as I can. So this is the virtual machine. So virtually I can allocate any number of CPU, any number of processor, any number of CPUs for this virtual machine. And again, out of 64 GB RAM, I can associate, let's say 10 GB or 15 GB of RAM to this associate and associate with that CentOS, and then the CentOS will run. This is the virtualized system. So if I go back here, this is virtualized processor, virtualized memory. This is virtualized disk space. It has got 2 terabytes of SSD. So probably I can associate, let's say 60 or 20 GB out of it. So that is a virtual hard drive for me, but physical hard drive for this operating system running inside that virtual machine. And if I start that virtual machine, it will start and it will continue that CentOS application, the CentOS operating system. So because this is a virtual machine, this virtual machine is going to have the virtual key, virtual hardware, and that's why it's called as hardware virtualization. In case of container, because we are sharing the operating system, this is operating system virtualization. So that's the big difference between a containerized deployment and virtualized deployment. Guys, can you please tell me whether have you understood this, the difference between physical, virtual, and containerized deployment? Yes, we'll see those answers in a minute or two. Okay, so if you have got the difference between them, now we can start talking about some more details about it. For example, what are the differences? What are the major differences between them? Very quickly, So when you talk about the virtualization, I mentioned that it is a hardware level virtualization, meaning you are going to virtualize your hardware. Whereas in case of container, this is operating system virtualization. This is a heavyweight, bigger in size. This is a lightweight and smaller in size because of operating system. And again, this is lower in size or smaller in size or lightweight inside it just because of no operating system. That's the major win for container. This is slow provisioning because this is a real operating system. It requires booting. This is the real time and fast provisioning because there is no booting. So when you start container, it immediately starts. There is no booting process. There is no operating system there. It has got the limited performance because this is the software base. The virtual machine is software. It is going to have the virtual hardware. But this is going to be a native performance because it is going to share the operating system. My God, operating system plus a hardware. So it is going to share the physical hardware and physical operating system. That's the reason you will get the better performance than virtual machine. It's going to be fully isolated in a sense because they are going to run as two separate virtual machines. They will not interact with each other. One is an operating system application running in one operating system. Another application is running in another operating system. They will not be able to talk to each other. That's full isolation. This is process-based isolation or process level isolation because, as I'll show you later, the containers will be considered or will be treated as processes. Okay, so that's the main reason why we are kind of saying the containers are process level isolations. Guys, I know it's very difficult, but trust me, when we are looking at all of these points are there in your so-called DCA syllabus. I'm not wasting your time. I'm not just kind of giving you the information which you don't need. All of these things are there. For example, process level isolation is one of the requirements, one of the points in the container image creation and the containers point. Like how do you prefer or how do you show that a container is a process? So that is one of the things there. I'll show that practically, but this is where we are looking at. Okay, so more secure because we are going to getting the full operating system. Less secure because that's a process level virtualization. A container can not easily but can access the data from the another container. So less secure there. Each VM has a separate OS. Should I say it's a disadvantage? Yes, it is. Excuse me. Each container each container shares the operating system resources on your physical machine. It boots in minutes while it boots in seconds. There is no boot actually. I mean, you start the container, it will be available in seconds. It is it's very difficult to find the pre-configured VM, but pre-configured containers are readily available, and we'll see that later. I mean, when we go for something as a Docker Hub, there are millions of images. You can download them and you can start your containers. And that is the way we are also creating our containers later. It can be easily moved from one operating system to another operating system, or it can be updated with the new version of operating system. Like today I'm running, let's say 20.04. So if I want to go for Ubuntu 20.10, I can do it. If I'm running, let's say Windows 10 here, I can tomorrow update if the Windows server is getting released, maybe 2020 server. Now it is 2016 server, I guess. So if the 2020 server comes in, I can update this operating system there. So updating virtual machine is possible, but the containers are destroyed and recreated because remember this, containers are something called as immutable. Immutable means once created, you cannot update the container. You cannot add anything to the container. It's not possible because that's kind of immutable. It cannot store the data on it. Once the container is destroyed, you are going to lose every single thing. That's the reason there is another kind of a domain called as storage and volumes. So there we'll see how the containers, if they want to store the data, how they can store it outside the container itself. And finally, creating VM is going to take longer time because it has to be configured with the virtual hardware components, and then the operating systems. It is going to install the operating systems first, and then it will get provisioned. It's going to take longer time. Containers can be created in fraction of second because it just starting the container from only the application source code and the binaries. That's it. We don't need anything other than that. That's it. And that's the reason this is the solution people are looking for. And that is the reason why we are in this mode, or why we are in this course. Okay, so does that mean we are not going to use the virtualization at all and we are going to use only containerization? No, it's not like that. Virtualization is still there. It's not like virtualization is deprecated and we are going to go with the containerization. It's not like that. Rather, we are going to use best of both the worlds. In a sense, these days, now if you look at, let's say, the cloud environment, let's say if you look at one, let's say AWS, for example. In AWS, when we are creating a virtual machine, it's called as EC2. And this EC2 as a virtual machine, on top of that, I can run multiple containers. Or maybe right now also, you see here, I'm running a physical operating system that's Mac. On top of that, I'm running Ubuntu. And inside the Ubuntu, I can also go for, let's say, a container runtime, and I can create multiple containers there as well. So it is not like we are going to use only containers, but we are going to use containerization and virtualization together. It's like best of both the worlds. So we want to use best of both the worlds, and that is how we are going to do the job. So in the real time, or in the cloud environment, for example, we use the physical machine, we use operating system, or maybe type 1 hypervisor on top of it, depending again where you are running it. Sometimes it is going to be type 1 for cloud providers, and sometimes it is going to be type 2 for you, excuse me, as a developers or as a testers. So on top of that, you will create your virtual machines like this or this, or you can run your application directly inside the virtual machine, or maybe you will install the container runtime like Docker on top of it, and then you will run them as containers. So we are kind of using best from both the worlds. So we still are using virtualization. Please understand that. And getting containerization in the picture does not mean we are going to say goodbye to virtualization. Virtualization will stay. Virtualization will be there. On top of the virtualization, we have to go for containerization. So instead of running the applications directly inside the virtualized or virtual environment or the virtual machines, we are installing the container runtime inside it, and then we are running the applications inside the container. That is the way we are doing the stuff right now these days. So this is how the containerization and virtualization will be used hand in hand. I mean, they will go hand in hand, and that's how the things will be seen in the real environment. Okay. Let's see a couple of questions. In container, we need to install JVM in case of Java application, or it refers to JVM. Yeah, we have to install. It's not like we have to install it. We'll configure an image which is going to install JVM for us. I'll show you that practically. You will understand that later. What container is exactly? It's not clear. Can you please repeat it once? No problem. Who's that? Riddhi. When you talk about the container, container is the way you are going to put your application source code. This is my application, and your applications required binaries or libraries. When I say binaries or libraries, it can be, for example, JVM, it can be Python, it can be CLR, it can be C++ environment system, so on and so forth. Whatever application you are developing here, if it is a Java application, you will put JVM. If it is a Python application, you will install Python. If it is a .NET application, you will install, let's say, CLR. If it is a C++ application, you will use C++ runtime, so on and so forth. So that is the way the containers will be created. That is the way the containers will be treated. Hopefully you must have got the answer. Arshad, your question, if we are deploying multiple containers, then how are the operating system binaries, or how OS binaries that are need are shared between the containers? Docker does it. How is the limit of containers that can be deleted? Okay, so how is it getting done? The Docker itself will make all these containers to share the operating systems here. I'm sorry, in this case, the share the operating system here. So this is the Docker, or this is the container runtime, which while running the container will make use of the physical operating system rather than having a virtual operating system inside the container. So it is a Docker which is doing it. I mean, don't say Docker, say container runtime, because there are multiple container runtimes available. For example, when I say container runtime, there are a couple of options. For example, Docker is one of the de facto standards there. There is something called as the container D. There is something called as LXC. There is something called as LXD, so on and so forth. So there are a couple of options there. So all of them will make use of physical operating system rather than creating a virtual operating system like the virtual machine. Virtual machine will use this. The Docker will use the operating system on below it, which is running on the on that host itself. So that's how it is going to do this. Can we say containers is nothing but running instance of an application? Yes, you can say that. That's the reason why he called it as a process. But it's not the process which looks like the other processes. It's little bit special process. Why? We'll see that in a moment. Can we run the container virtual machine? Is it a good practice? Exactly. This is how the real-time environment or real-time implementation will go. Later on, if time permits, I'll show you how to configure containers on AWS by using ECS, if time permits. There you will see exactly same behavior there. Okay. Okay. How will be application can run only Mac OS when the Windows work? I'll show you that. No problem. Please repeat immutable. Definitely not right now. Later on, I'll show you practically what do you mean by immutable. Just talking about it will not give you the confidence, Ashraf. So better we will see that practically. Okay. Is it necessary to have hypervisor to implement a containerization? Not at all. When did I say that? Hypervisor is needed. This is the actual diagram of getting the containers, in the picture. Where do you see hypervisor? This is an example where the hypervisor or virtualization and containerization, they will go hand in hand. Okay. Hypervisor is not needed for containerization. It is needed for virtualization. What is the Azure difference between Azure App Service and container? We'll talk about that. Uh, Atul, your question, what that means? Only every OS has got a different image. Yes, that's what we are going to see later. Every OS is going to have a different image. Absolutely. Rupali, your question, are the containers specific to operating system? Yes, that is the reason. I mean, containers are specific to operating system in a sense. When we are using, let's say, Docker, by default, Docker is going to give you a Linux container. Linux container in a sense, the shared operating system or the operating system on your physical machine has to be Linux. It has to have a Linux kernel, because unless it is Linux kernel, no container, no Docker container can run, because Docker uses Linux kernel on top of it. I mean, to run the containers behind the scene. Then how is it going to run that on Windows or Mac? I'll explain that. How does it do the job? Okay. Just wait, you will see that. Sachin, is that the JVM specially developed for the image when we run the Java app? Yeah, JVM is the Java virtual machine where it is going to be used for developing, sorry, not developing, running Java applications there. Okay. Will the VM container use the VM host or the host OS? VM run container, not getting you what exactly you want to say there, Mangesh. So when a container is running inside the virtual machine, it is going to use this operating system. When the containers are running on your physical operating system, it is going to use this operating system. The container is going to use that operating system. The container runtime is installed on. That's how it is going to do it. Okay. Prashant, how will, if we use type 1 virtualization, how Docker will run? Doesn't matter. When we are using what type 1 virtualization, that is exactly what you are seeing right here. This virtualization is a type 1 virtualization where you will have to create a virtual machine first. You will have to put an operating system inside it. You'll have to put the Docker inside it or container runtime inside it, and then you will run the container. So Prashant, this is the way you should do it. Okay. Mayur, when it comes to hypervisor, can we say that for production environment we use type 1 and for development we'll use type 2? Absolutely right. For production environment, we use type 1. That's what I said. It's the cloud provider's requirement. And type 2 is used for only development and testing purpose. That's it. Okay. Type 1 VM itself is an operating system. Absolutely. Type 1 itself is an operating system. Sachin, I mean, in a special version of JVM for Docker, only which it's used. No. It's the real version of JVM. There is nothing different than JVM is JVM for Docker or JVM for virtual machine. JVM is JVM. Doesn't matter whether it is running in Docker or virtual machine or on the physical machine. JVM is always a JVM. Okay. Okay, so I think you got the clear picture now. So just to get the things revised very quickly, we saw what is a virtual machine. I mean, what are the different options available? Traditional deployment, virtualized deployment, and containerized deployment. We saw the requirement of having containers in the first place. We saw what is the scaling problem. We saw two solutions, vertical and horizontal. And I said that in the real world, we follow horizontal scaling. And when we want to go for horizontal scaling, virtual machines are slow to provision. That's the reason why we want to go for containers. And that's where the containers are needed. And if the containers are needed, container runtime is also needed. So which container runtime should I go for? So if I want to go for a container runtime, one of the best options available is nothing but the Docker. And that's where the Docker will come. Okay. So probably Docker is the one where we are going to start talking about how the things can be moved, how the things can be executed, or how the containers can be created. So what is a Docker? In short, a Docker is a containerization platform. Maybe when you say containerization platform, that is going to enable the developer to build, test, deploy the application easily, reliably inside containers. That is more important. In short, last time I said that multiple times that there is something called as a container runtime. So container runtime here is nothing but given by Docker. So the Docker is nothing but the container runtime, and that container runtime is going to make use of the containerized platforms, and then it's going to run your container. That's the main job of a Docker. So Docker host runs multiple containers, maintaining the isolation between the containers. So generally one container cannot directly connect to another container. So this is C1 and C2. Both of them are not directly connected. They will be connected in a different fashion. We'll see that how they will share the data with each other by using something called as a volume and other stuff later. But they're not directly connected to each other. So this is the job of a Docker, to isolate the container so that they will follow some security principles. Prabal, what do we need to install to do practical along with you? I'll talk about this. I'll show you how to install it. Okay, don't worry. I'll show you all the steps. Let's go to that point and I'll show you how to do that installation. Madhukar, when we host an application virtualized environment, request reaches the host machine first, or will it reach the virtual machine directly? Of course, it will reach to the host machine first, and from host machine, it will reach to the virtual machine, naturally. Anshul, is there any container runtime and why Docker is much famous? You got it now because that's what we are going to talk about now. So, answer to your question, Anshul, is this: why Docker? Isn't there any other option? Yes, there are a couple of other options. Excuse me. I gave you earlier the couple of options as well: LXC, LXD, Containerd, Cryo. There are a couple of different options available. But why are we choosing Docker? Couple of answers. It's easy. It provides an easy way to create an application deployable package. Those deployable packages are called as images. And we'll see how simple is that to create an image using Docker. We'll see. Developers can create ready to run containerized applications. And it's, believe me, it's very, very, very simple to use Docker in the first place. It provides consistent computing environments. In a sense, you can run Docker anywhere. Doesn't matter. Operating system, all the operating systems are by default supported. So operating system is not a problem. It works equally well on premise or on the cloud environment as well. So today, while testing, you can run it on your machine or any of the servers which is there in your company in premise or on premise machine. Or later on, once you are done with the testing, you can directly run that container on the production environment on somewhere in the AWS or Azure or Google Cloud, and you will get the equal performance. Not a single line of code need to be changed when you are running from one environment to another environment, when you are transitioning from one environment to another environment, so that is the reason why it is going to be very important. Finally, it's lightweight when you compare with VM. It's not the Docker actually, but it's the container which is going to provide a better solution or lightweight solution than the virtual machine, and that's the reason why we are talking about this. And so this is the answer to your question. Now, once we understand why Docker, very quickly, let's see where the Docker is coming from. I mean, who started Docker? So, what was the kind of origin of Docker, where it is started, why it is so famous, why people are using Docker, so on and so forth. See, Docker Incorporated, started by Solomon Hykes, is behind the Docker tool. So, this is the company behind it, Docker Incorporated. If you get a chance, I would recommend to go on YouTube and look at one of the videos where Solomon Hykes has given an interview, and you will see why he created Docker in the first place. He's a very famous person, Solomon Hykes. So go on the YouTube and you will find his interview there. Okay, so Docker Incorporated started as a PaaS provider as a .cloud. PaaS stands for Platform as a Service. So the company, before coming into the actual containers, they were providing the platform, and the original name of that company was .cloud. In 2013, the .cloud became the Docker Incorporated. The Docker was using Linux container or LXC before version 0.9. It's not what we are doing right now. It was earlier version. In after 0.9, 2014, Docker replaced the LXC with its own library, libcontainer, which is developed in Go programming language, one of the fastest or one of the best performing languages, Go. So Docker is developed in Go. It is using a library, or it's using a kind of a heart of the Docker, which is called as a libcontainer. So libcontainer is providing everything that you are using now. So it's not the only solution for the containers. So I said that earlier, that it's not the only one. There is something like a FreeBSD gel launched in 2000. That's another solution for containerization. LXD is the next generation system container management on top of LXC and REST APIs. Google has its own, very funny, Google has its own open source container technology called as LMCTFY. Let me contain that for you. LMCTFY. That's the option given by Google. RKT, Rocket, is another option which is going to run your application inside the containers. So yes, that is the one which is going to be kind of an option for you if you don't want to go for Docker. So you can go for LXD, LXC, go for Rocket, go for Google's LMCTFY and FreeBSD gel. Go and Golang is exactly similar. Yes. Now, if you want to go for Docker, what are different options available for us? I mean, which option should we go for? There are two options. One is called as a Docker C, C for community, and there's another one, something called as a Docker EE. EE stands for Enterprise Edition. For your DCA, you will have to use this and this, both of them. There is an entire, image creation, image updating, image signing. All of these things will come inside this topic. security. Again, one of the domains in your certification will require you to install, configure all of that stuff in Docker EE. We'll see that later. So this is Docker Enterprise Edition. It's the paid solution. And this is the Docker CE, which is Community Edition, which is a free of cost. So you can download it, you can install it, and then you can do whatever you want to do with that Docker. So what are the different features? Both Docker CE and Docker E, both of them provides the container engine with the orchestration. Orchestration is the way we are going to manage multiple containers. You know that last time I talked about this fact that when we go for horizontal scaling, there are multiple containers will need to, if they are kind of getting crashed somewhere, we need to restart or we need to replace them. So who will do that? There is a tool which is going to do this, and this tool is called as the orchestrator. So both CE and EE, both of them will provide the orchestration, which is called the Docker Swarm by default. Both of them provides the networking, both of them provides the security, both of them provides the volume, storage, and every single thing there. So what is the difference then? The difference is certified infrastructure, plugins, ISV containers. We'll see that later in the EE solution. What do you mean by ISV containers and what do you mean by the certified infrastructure means? How we're going to get your images signed, certified. We'll see that later. Of course, image management in a sense, how to create the image repository, how to sign the images, how to make your images secure is what you will find only in EE, not there in CE. It also has the container app management in EE, and secure image signing or scanning is also there inside the Docker EE, where all of these features are paid features. I mean, you have to pay the license cost for that. There are no such features inside the CE. That's the reason CE is a free and it's an open source. So you can start using that CE. You are going to download that CE today and we'll start working on it. We'll use it today, tomorrow, next Saturday, and on Sunday, we'll switch to EE and we'll explore all the features needed inside the Docker EE, and we'll cover all the points for your so-called exam. Okay, so these are Docker editions. How do I choose one of them? How do I go for one of them? How do I choose that? To choose this, there is a simple example. When you are running this application on your desktop, you can go for like Windows or Mac. This is called as a Docker desktop, which is available on both Windows and Mac. And that's a free of cost. You don't have to pay any cost for that. So it installs a Docker C behind the scene, and then it has the community support. So if you're stuck somewhere or if you have any question, you can ask the question to that community and the community might help you there. When you talk about the Docker CE Community Edition, it is going to provide the server or VM for testing or maybe development. So that's where the CE is needed. It's also free, which is used behind the Docker desktop. It runs on Windows and on Mac. So behind the scene, the Docker desktop uses the Docker CE. It's known as CE, stands for Community Edition. And again, community support is provided. This is the one which is where you can say it's a production ready, and this is where it is used in the production environment. So production applications which are running in the data center or cloud will use a Docker EE, which is where we are going to have all those extra features which are missing in CE. Now that's where the Docker EE will come into picture. So those features are given by enterprise editions. Of course, this is the paid license, so you'll have to pay for that. It runs on Windows and Linux, not on Mac. It's not available on Mac. You'll have to run that inside different containers. We'll see that. It's called as Enterprise Edition, and the full support is available from Docker. It includes the advanced features which I mentioned earlier, and we are going to explore them practically later. So we'll see that. Don't worry. Excuse me. So that is how we can choose the platform, either CE or EE, depending on your requirement. If you are running it on Mac or Windows, you will use the Docker desktop. If you are using the Docker desktop, then it is going to use a Docker CE behind the scene. And if you want to go for production environment, then probably you are going to run inside the Docker EE, where the Docker EE is nothing but Docker Enterprise Edition. Linux is not mentioned in the CE. Does that mean that we can't use that on Linux? No, it is used in Linux, but it uses a different format. I'll mention this. What do you mean by that? Okay. Excuse me. We need to pay for Docker EE, but we don't want to pay. There is no option. There is a free license, not free, but trial license is available for a month. So don't worry, Prabal. Even if you don't want to pay for it, you still have to pay for it in the production environment. But for testing purpose and for certification purpose, there is a 1 month trial. So you can go for that 1 month, learn all the stuff, go for the exam, and once you get the certification, and once you go to the company will pay for that license cost. You know? Pratik, SaaS, PaaS, both are same or different? Of course, they are different. SaaS means software as a service. PaaS means it's platform as a service. Prince, your question, what kind of runtime Docker will provide to the running containers? We'll see that practically, you know. Yeah, 1 month is more than enough for testing and for passing your exam. Okay, so these are the options available for you. Now let us start talking about the Docker architectures. So when we install Docker, what all different things will be installed and how the Docker will run behind the stuff. But before that, I'm going to jump directly onto the installation part, and I'll show you first how to get the things installed. We'll start installation, we'll take a break, and then we'll come back, and then we'll start about the Docker architecture. So by the time we are taking the break, your installation will also get completed. And when we come after the break, we'll do the things together. Is that okay for all of you? I hope that is okay, because you can do the things along with me, and I want you to do the things along with me. Okay. I'm going to show you the instructions for all the 3 operating systems one by one. The simplest one first, Mac. So if you are on Mac, you go back to the Mac. I'm sorry, I forgot to show you this. This is the link actually I opened, but I forgot to share that with you. This is the Docker certification. One sec, I'll put that for everyone. This is the link where you can find all the requirement for passing the exam. And this is exactly what I just put inside that inside that slides there, you know. So I mentioned all of these points. So that's what I said. It's not like we have created that course. This is something that syllabus, which is given by Docker, you know. So that is where we are going to go for the Docker certification exam. So this is the preparation guide. This is officially given by Docker. Okay, exam fees, $150 for DCA, $300 for CKAD, and $300 for CKA. $150 for CJE for Jenkins, and I think that is it, right? Rest is $196 per certification. The good thing is for DCA there is no second chance. I mean, if you pass in one single try, it's good. If not, then you lose your money. For CJ, for Jenkins, you lose the money if you don't pass in the first attempt. But for CKAD, even if you lose in the first attempt, it's okay. You will get a second chance free of cost. So it's like in $300, you will get 2 chances. You can pass in any one of the chances, and then you will still be having that certification under your belt. Okay. Yep. So that's why it is a little bit costlier. I told you the certifications are costlier, and they really carry the value. You know, that's the reason why they are costly. Okay, anyways, I'll show you how to install install Docker on Mac, Docker on Windows, and Docker on Linux. Okay, so this is where we are going to install Docker on Mac first. So just search for Docker on Mac. This is called as a Docker desktop. All we have to do here is go to that link. That's the only link you will have, and download from the Docker Hub. Docker Hub is a registry. Don't worry about that. I'll mention what is a registry, how you will configure your own registry later in Docker EE and stuff like that. Right now, go to this link. I'll just put that link right here on your chat. So just go to that link and click on the Get Docker. It's as simple as that. I mean, I already have it, but it's getting downloaded. It's hardly 30-40 minutes. It doesn't matter. So this is where I don't have to. Do I have it here, or did I delete it? No, it's still there. So you are going to get download. I mean, you are going to get downloaded this one. Hopefully it will get downloaded in a minute or two. It's almost like 535 MB. So you download it, you install it, and installation is as simple as that. You are on Mac. Mac is even the simplest one. But when you are on Mac, all we have to do here is just drag and drop, and that is done. On my case, I'm already having it. That's the reason I'm not going to do it. But otherwise, you know, it's going to be as simple as that. So once it gets installed, probably you are going to see that Docker icon right there. Just open it, and it will open, and it will start running as a Docker desktop. This is called as a Docker desktop. I'm already running my Mongo database right inside this because I generally run all my databases in my containers. I try to use containers as much as I can. This is the brand new machine I'm using today, starting from today itself. That's the reason you cannot see anything here. If I switch back to my another machine, you will see ton of things going on in my Docker containers. This is the fresh machine started using for today itself. Anyway, so that's the reason why we are having only Mongo here. Otherwise, you will see Mongo, Redis, MySQL, Postgres, all of them running here. Other than that, Apache and all of that stuff. I use containers in my daily environment as much as I can. Anyways, so that's how simple it is on Mac. Let's go for another simple installation for Windows. So probably, yeah, it's not like a new machine. I purchased today. I purchased it 2 months before, but I didn't get any chance to open it. So I started using that machine starting from today itself. I thought maybe today is the day where we are starting with the new course. Let's use it. And this is the pro version. When I want to start this machine, virtual machine, which is running right now, it is having 8 GB of RAM. This virtual machine is having 8 GB of RAM. So there are 64 GB RAM available. That's the reason I said it's better to switch on this machine and start using it for this entire course, DCA and Kubernetes. For Kubernetes, I'm going to create a cluster of 8 nodes with master. We'll use this environment here. That's the reason I switched this machine starting from today. That's the only reason. Anyways, so coming back to the Windows world, Windows world is again exactly similar. You will open the Windows, the Docker for Windows, search for directly Docker Windows or Docker for Windows. Again, same like Mac, you go to that link and then you will download it. It's going to be exactly similar. Let me put this link right here. You can search on your own as well. It's just Docker for Windows. You can, you can copy and paste. That's the reason I hate Windows, not comfortable with Windows at all. So there it is. Just download this one here. Again, say download from Docker Hub. It will download it. And once it gets downloaded, once it gets downloaded, you will have an icon there. So probably if I just click on that link, it will go to that link. And again, we are going to start downloading it. On my machine, I already have downloaded it. So it's okay. Let me just download it for a second. It's almost like 460 megabytes. I'm having a good speed today, so that's good. And probably once it is done, you see, it's almost done. It's there, and probably this is the Docker desktop installer. So all you have to do here is double click on that and start installing. You are on Windows, so you will start doing the stuff there. Just say yes, and it will start installing. Just say next, 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 next. You are done. On my case, I already have installed, so I don't have to worry about it. On your machine, you will start doing the stuff there. Okay, so that's how you are going to install it on Windows. But beware about few things. On Windows, there are few features will be missing when we talk about the syllabus, when we talk about the DCA part. There are few things which you cannot configure or you cannot do on Windows. So be aware about that. If you ask me which one is better, Mac, Windows, or Ubuntu, I would say go for Ubuntu because that's a true native, the native performance and the native Docker installation. And that's where it is kind of needed. So that's it. When we are doing this one here, again, just open that, install that Docker for Windows. And once it gets installed, probably you will just run that same, just double click on that icon and probably you will see that it is running. So this is where it is running. That's it. I'm going to go back on Linux and I'll show you those instructions here. In Linux, it is going to take a little bit time because what the hell? Okay, so here I'm going to search for again Docker on Ubuntu. That's it. So I'm going to install that same. There are instructions and there are commands. All we have to do here is as simple as that. Open the terminal. Anything for Fedora? Yes, you can do the same thing. You see here the options are. I'm going to go back here and just click on that link and you will see here there is an option for Fedora, there's an option for Debian, there's an option for CentOS as well. I generally use Ubuntu or CentOS. I use Ubuntu or CentOS as per my need. Sometimes Ubuntu, sometimes CentOS. but the instructions are almost similar. Instead of using apt-get, you will use Fedora's package manager. Something like maybe when you are in Fedora, it could be yum, for example, or it could be DNF. DNF is the open source version of, or maybe it's an open version of exactly for package management, which you can use inside CentOS as a yum. So yum internally uses DNF. Those who are using it probably know that, right? So Shailendra, this is DNF. Maybe if you are going for CentOS, you'll have to use yum, and if you are using Ubuntu, you are going to use apt-get. So doesn't matter which one you are using, the instruction will almost similar. So that is how we can do it. I don't have Mac. You don't have to have a Mac, Pratik. You can use Windows or you can use Linux as well. Exactly. CentOS Linux is going to be yum. For Fedora, it is a DNF. For Debian and for Ubuntu, it's going to be apt-get. Rest of the instructions will remain same. If you already have got older version installed, first uninstall them because we are going to install the latest one and just follow the instructions. Like update your sudo cache. I'm sorry, the apt cache. Okay, so that is it. Install, I mean, on my machine, everything is installed. So I'm not going to install it again, but that's how we are going to do it. For Windows, it is DMG file. Now it is asking for some app. No. You don't have to use DMG. For Windows, it's going to be, why is it going for, you're searching for you're searching for Mac. It has to be desktop, sorry, the Docker desktop for Windows. Search for it. You are going to get it as an installer, you know. So that installer is either MSI or EXE. So probably this is the one that you have to use. Hey, just go away. I don't want to see you. Anyway, so that is the installer here. Just use that installer, okay? It's an EXE, exactly. EXE or MSI, whatever, Microsoft installer or EXE, whatever. So just follow that, update your cache, install the prerequisite, like maybe app transport, HTTPS, CS certificates, curl, or GNU-PG agent, or software properties component, blah, blah, blah. So just get them installed, they're the prerequisites. Next, add the SSH, add the key. That key is the JPG key, which is used for validating all of your Debian sources. I'm sorry, all of your Docker Debian sources. For Debian, for Ubuntu, I'm sorry, for Fedora and for CentOS, we'll have to use the different sources there. And once you add them, it's like get all of these packages installed. Go there, install that. It's going to take hardly a couple of minutes depending on your internet connection. My case, I already have installed them. Then add this JPG key. So this is JPG key. I already have added. I don't have to do it. So it's going to tell me that it's already added. It's okay. Finally, you are going to add that source. Just copy and paste. I'm going to copy here, but I'm not going to press enter because I already have done that earlier. And finally, just get the things updated again like this. And finally, you know, you install the Docker CE, Docker CE CLI, and containerd.io. So install all of these tools and hopefully you are done. That's it. On my case, it's already been done, and that's how we are going to do it. Now, what is the criteria to see whether the Docker has been installed on your machine successfully or not? So once you are done, use this command without knowing the details behind it or without knowing what it does. Just use this command. Say docker image ls. That's it. Oh, one more thing. Before you continue with this command, use, if you are on Ubuntu or if you are on Fedora, for example, use this command sudo user add -a-g, whatever is your current user. In my case, it is Amit K, and use the Docker as a group. So we are adding the current user inside the Docker group. Don't forget this command. That is needed for Ubuntu as well as for CentOS as well as for Ubuntu for Fedora. So don't forget that. I'm going to put it here. Can't copy this from there. Fine. So I'll put this command here. It's sudo user add -a capital G, A for append, G for group, username. I'm adding it on your chat there. So install it, then run this command. username and the Docker. That's it. I did that on your chat, copy and paste it. Yes, we can copy it, Shivam, but it's not letting me to share with you as I'm running this inside VM and I've not enabled sharing between my host and my guest machine. That's the reason. I can do it from Windows because I enabled it for Windows, or for Windows it by default gets enabled. For Ubuntu, I'll have to change it. I forgot to do that. So it's not a big deal. You can do it there itself. Okay, so I added that command there. It'll be easy for you to do it. This command is not needed for Windows. This command is not needed for Mac. This command is needed only for Ubuntu, Fedora, CentOS, means Linux. That's it. Okay, so I hope if I do it on my machine, even though you will see something like repository tag, image ID created, size, that's okay. You are not expected to see anything like this. If you go for Windows, maybe on Windows, I hate to use that command prompt. I use a special application called as CMDR, or it's called as Commander. I don't know how many of you Windows user know about it, but I'm going to use this one here, and we'll use the same command, Docker Docker image ls. There is no there is no image here on my Windows machine yet. No big deal. We will do that later. This is on Windows, and the same command I'm going to use on my Mac. So I'm going to come back here and use the command, same command, Docker image ls, and I'll see a couple of images out there. So there is a Mongo and there is an Alpine. So use the same command, and that will tell you like whether it is installed properly or not. Can we use CMD or not? Of course, yes, you can. I'm not saying don't use it. You can, and see the same thing. Docker, what the hell? Docker image ls. I hate that command prompt, you see. So this is the same command here, Docker image ls. When I use Windows, and that happens only once in a while, when there is a project and when there is a requirement. Otherwise, I don't use Windows at all. So you can use Windows, and when I use Windows, I use this command prompt. That's called a CMDR. Give it a try. It's one of the best one there. It's like Cygwin. It's better than Cygwin, by the way, on Windows. So you can run all of your Linux commands here. I mean, I can't live with without Linux, you know. Right now, it's a mini version. That's why it is not recognized in LS. If I go for a full version, I can use LS and all the Linux commands here. So I've not installed a full version on this one. This is a virtual machine. I just installed it today itself for demonstration. After today, I'm going to delete this virtual machine. I don't want to keep Windows on my machine. This is needed only when there is a real requirement in the application. Otherwise, I don't use Windows at all. Anyways. Okay, so what's the best environment you would suggest to practice these things? Linux, Ubuntu, best option. Prince, this Docker image is running inside running instance of containers. We'll talk about this. We'll talk about that. Do we need anything else for Windows? Nope. There is one Linux container, Linux driver. It will ask you to install. Just say install. It will ask you to restart your machine. Let it restart, and then you are done. Okay. On Windows, it's not needed on Linux. It's not needed on Mac. Should we install CMDR? No. You don't have to. It's just a simple utility. I mean, I love this. I'm just sharing that with you. If you like, just install it. Not a big deal. Okay. Yes, it's up to you. Docker image ls, that means your image Docker has not been started. Start the Docker application, you know. So when you install Docker on your Windows or on your Linux, you'll have to start that, you know. So here it is, Docker desktop. Just start this Docker desktop when you install on your Windows, or when you are installing on Mac, start that Docker desktop here. So this is the Docker desktop. Probably I'm going to open that right here. And this is where my Docker desktop is running. You see, that's a Docker desktop here. That's the Docker desktop here. Where is it? Here. So there is no container running. That's okay. This is Docker desktop for Windows, and that is a Docker desktop for Mac. There is no Docker desktop for Linux. This is the pure, or maybe the true Linux container. So we don't need any Docker desktop or desktop version of it. Yes, Devakar, it's okay. We'll talk about that. Don't worry about that. Don't even read this one. Just use this command. Make sure that Docker is installed properly. Okay. It's going to take a long time. I know. It's fine. We'll take a break in between. So probably you continue with the installation, it will ask you to restart your application, restart your machine in between once if you're on Windows. On Linux and on Mac, it's not needed, but on Windows it is needed. So go on go on installation. Okay, so go on installation, continue installation, get it installed properly, and once we come after the break, we will continue together. Okay. What is the minimum requirement? Minimum requirement is like you should have 8 GB of RAM if you are installing it on your machine, and if you want to do all of these things without having any problem, it's recommended. But still, you can do that on 4 GB of RAM as well. It's not like it won't work. It will, but it will work slowly. Okay. Even if you are using EC2 instance, Praveen, it will be better. Not a big deal. You just have to have a good internet connection. That's it. So you can also do that on EC2 instance as well. The instructions will remain same. Exactly what I showed you here on Linux part, it will be just you are executing there on the EC2 instance. Everything will remain same. Rishabh, can we use a Linux subsystem Ubuntu on Windows? We'll talk about this. That's the main reason why I want you to first install it, and we'll do all of these things together practically. Okay, we'll see that. Okay, so guys, let's take a 15 minutes break in between, and after the break, we'll continue with the next point. Okay, let the installation continue. Is that okay with all of you guys? Okay, so take a break, grab a cup of coffee if you need, and then come back and we'll continue further. Hopefully everyone is still there, right? I see 100 people already have dropped off. I can understand. That's okay. Fine. So probably it is still installing, not a big deal. You can do that stuff later. It's not like you have to do all of these things right with me. You can do that later if you, I mean, if it is taking some time. It's okay, not a big deal. Okay, so now we have seen some basics of it. Let us come back and let us understand the architecture of Docker, and let's start talking about all the basic stuff that we need to understand in order to run all the applications inside the container. Okay, so let us see what are the different things that we need to know. So very first thing, we have to understand what a Docker architecture is. Now, when we talk about the Docker, when we are installing Docker, there are a couple of things which will get installed on your machine. The first thing is like Docker daemon, which is called as Docker-D. This is the heart of your Docker. This is where the Docker's main process is going to be installed. Tejas, for that you will have to go to the BIOS settings and we'll have to install, or we have to enable virtualization. Without that, you cannot do this. If your CPU doesn't support it, you can't install that. It should be at least Core i3 onwards. So if you're using any processor below Core i3 or below Core i, then I think it won't work. If it is i5, it has to work. Go to BIOS and enable the virtualization bit, and it will work for you. Okay. Abhijit, run Docker, and then it will solve your problem. Okay, guys, understand this first. When you install Docker, it is going to install a couple of things. One of the main or one of the core things is like Docker daemon. This is the main daemon. This is the main process. This is the main service, which is going to do all of the jobs for you. It is continuously going to run behind the scene. It is a service, so it has to run continuously. So that's the reason why it is called as a daemon. Daemon means it's the one which is going to run continuously. It manages all the containers, and that is the one which is going to run all the containers for you. That's a Docker-D. Now it's like this. Let me go back here and create a new page, and it's like this. So what happens here is it installs a main process called as a Docker D. This is the daemon. D stands for daemon. Most of the times, probably when you are in Linux, you will see all the daemons, all the processes which are continuously running, they are having a suffix called as something like a D. So Docker D means it's a Docker daemon. So this Docker daemon is going to do all the job for you. But to make use of that Docker D exposes all the REST APIs. REST stands for representational state transfer. So this is a kind of a service, or this is a kind of the APIs which will be exposed by this Docker D in order to deal with it. So probably this is the way you can say the Docker D is going to work behind the scene. So this is the core part of Docker. This is the one which is going to do all the stuff for you. But how will you use that Docker D in order to download an image or create an image or create a container or manage the container? So how will you do this? To do this, excuse me, to do this, we have to use a client. This is the client, which is going to be the Docker command that you used earlier before. So the Docker command is the Docker client, which is going to consume those REST APIs and will provide all the different commands to deal with your images or to deal with your containers. It provides a command line interface. It is used to perform all the tasks in the Docker. So there are three components. One is the Docker D itself. That's the main part. That's the main service. It provides the REST APIs, and those REST APIs, if you want to call them, or if you want to create the images, we'll see what is an image right now in a minute. So this is an image. So if you want to use that image and create or spawn into something like a container, you will need a Docker container. So this is, I'm sorry, you will need a Docker command, and this Docker command is going to consume all of these APIs here. So all you have to do here is use that Docker and do whatever you want to do. So this Docker behind the scene will consume all the REST APIs provided by this Docker D, which is nothing but the service here. This is the overall picture of Docker. So when you are installing that Docker, this is going to give you the Docker D. That's the service. That's a service. That's a daemon. which is going to provide the REST APIs, which is going to be consumed by the client. Client is nothing but that Docker, which is going to give you an option to create the containers, images, configure the networkings, configure the volumes and stuff like that. So that is what we have used earlier there. Okay. So behind the scene, it uses, if you can recall, I mentioned that last time, behind the scene, it uses the lib container. So in 2014, after version 0.9, Docker replaced the LXC by the lib container. Lib container is a solution provided by Docker Incorporated, which is used to manage all the containers. So who is running the containers? It's Docker. But what in the Docker runs the container? It is the lib container. How does it do that? It does that by using three things. One is called as the namespaces. We'll understand that in a second. Second one is called as a C group or control groups. And third one is called as Union FS file system or Union FS, simple. Union file system or Union FS. Ashraf, you are able to hear some background noise. Was it me? Let me just see if someone has accidentally muted or unmuted. Oh, yes. No problem. I think a couple of you accidentally have got unmuted. No problem. Yes, it's fine. So now let us understand how the lib container works. See, this is the container D, which we have talked about. The container D behind the scene uses a lib container. This is the lib container D, or simply like a lib container. So this is the library lib container, which is going to provide three different things. Maybe one, two, and three. So one of them is called as a namespaces. Now, what is a namespace? We'll see that. Then there is something called as a C groups or control groups. And then there is a Union FS. So that is the big picture here. So what is that namespace? We'll see that now. The namespaces create, or namespace creates the isolated workspace, which limits what the container can see. So behind the scene, when you create a container, this is the whole story here. See here. This is my operating system, for example. This is the container one, let's say. This is the container two. So what container sees is nothing but the sandbox. Sandbox is nothing but whatever is there inside this box will be visible to the container. So for example, this container one is running an application app one. This container two is running an application app two. Then though they are running on the same host, though they are running by the same operating system, the C1 here will see only one application running. So for C1, it's like I'm using the entire machine, and inside that machine, I'm running only one application, app1. For C2, it says I'm running alone on this machine and I'm running only application 2. Behind the scene, it is an operating system which is managing the both containers like this. You know, it's exactly replicates our human behavior. We as a human, we think like we are doing the things. I mean, think about this for a second. I'm going in a philosophical way for a minute so that you can understand what is happening here. When we talk about something, we always say that I did that. Because of me, it has happened. Because of me, something is working. Because of me, someone has got something, you know. This is not the one, and this is not the actual this is not the actual way to think of it. You know what? We are not doing anything. Everything is driven by one supernatural power. We call it as a God. So we say that we are doing it. I say I have done that. It's not like I have done that. There is a God who is driving me to do it. It's exactly what is happening with the containers. Container C1 says, I am the supernatural, I am the super powerful here. I am running application 1. It doesn't know that there are many containers running on this operating system, you know. So exactly what is happening with the real life as well. This is the God and this is us. We think like we are doing it. It's the God which is driving every one of us. So they are kind of running the isolated environments. So this isolation has been done by using the namespaces. Namespace is the concept not given by Docker. It is the Linux concept. Even though you are not using Docker, namespaces are there inside the Linux environment as well. It provides a layer of isolation. So when it comes to isolate, This is the namespaces where it will help you, or namespace is going to help you to isolate the environment. Each container runs in a separate namespace. So this container can see what it is configured with. This container can see what it is configured with. C1 doesn't know that C2 is running. C2 doesn't know that C1 is running. It processes running in the namespaces can interact with each other, or each other processes, or use the resources which are part of that same namespace. In a sense, if the processes are started within the C1, then those processes will be accessible only within the C1. They will not cross compatible, or they will not cross reference each other. So applications running inside C1 will not be visible to application running inside the C2, and vice versa, because they are kind of isolated with namespaces. For example, every process will get a separate process ID in every container, separate network solution, network configuration for container, separate IPC, interprocess communication, and separate file system for every container. We'll see that practically happening in a moment. This is namespaces. Namespaces will isolate the container's environment. Now, sometimes, if you can recall the last example in the physical world, I said that if there are two applications running, if one application is using more resources, then second application will underperform. To avoid this scenario, we generally go for something called as a C group. C group is nothing but the control groups. Control groups means we can we can configure those containers to use restrictive resources. Restrictive resources, in a sense, I know this application is not going to need more than 2 GB of memory. So I will say, hey, you will run with only 2 GB of memory. So for C1, the entire machine is having only 2 GB. It doesn't know the entire machine is having, let's say, 64 GB of memory. And while configuration, we have said that it is going to use only 2 GB of one. Similarly, I know this application is going to need, let's say, 8 GB of memory. So I can say this is 8 GB. It will not go beyond 8 GB. This will not go beyond 2 GB. So this can be possible with the help of control groups, or C groups. So what is a C group? C group is going to allow us to configure the restrictive resources on those containers. It is used to share the available resources with the containers, or you can configure them as per the container's requirement. It optionally enforces the limits and the constraints on the resources group. It limits how much the container can see. This container sees only 2 GB. This container sees only 8 GB. That's it. Though 64 GB is available on that operating system on that machine. And for example, you can configure CPU, you can configure disk space, and you can configure the memory as well. How do we do that? I'll show you that later. This is one of the points in your so-called exam. So in exam, you might see a couple of questions on this part here. I mean, I myself have seen those questions, so you definitely can see one of the questions on resource limits. We'll see how to resource, or how to limit the resources while creating the containers later. Okay, so what if the C1 and C2 are using the shared resources? How do we achieve it? We'll see that. There is only one option, which is called as either network, or you can say volumes. Those things will be shared. Other than that, you cannot share anything. Prabal, control groups point 1, you can repeat. Point 1, control groups used to share the available resources with the container. Available resources means, for example, the RAM is available here as a 64 GB. Out of that, 2 GB will be given here, 8 GB will be given here. Remaining will be used by the operating system. That's how we are sharing the resources here. If the CPU is available with, let's say, 4 cores, and I know that this is going to need only 1 core, this is going to need only 2 cores. So I can say this C1 can see the entire machine having only 1 core, and this C2 can see entire machine having only 2 cores. So we can put the restrictions on top of the resources. That's how we can use the C group. Okay. Docker is not recognized the internal command. Restart your machine, Akshay, it will work. Rajendra, voice is lagging. Maybe it's your internet connection, I guess. Harshit, namespaces, C groups, union files are the part of OS kernel. Yes, part of the OS kernel. This is the Linux, which is providing all of these things. Namespaces and control groups are by default given by operating system, while UnionFS is given by the Docker. So It's not given by Docker, but Docker uses different union file systems. Now, what is a union file system? The union file system uses different layers when we want to create image, or it is layer based operating system. It's very lightweight and a very fast file system, and it's not the file system you are going to use it in a normal environment. In a normal environment, you might use NTFS for Windows or ext4 for Linux, or maybe AFS for Apple, or maybe for Mac. This is a special version or special file system given by Docker in order to create different images and use different containers out of those images. So that's a special one. Docker uses different variants of different union file systems. So there are different options. For example, AUFS, Advanced Multi-Layered Unification File System. That's one of the file systems which is following the UFS. Don't worry, I'll show you what you mean by layered file system in a very next example. There is something called as a BTRFS, B-tree-FS. It uses B-tree behind the scene. VFS, virtual file system, and there is a device mapper. All of them are the union file systems. The union file systems are giving the layer-based approach. What is the layer-based approach? I'll tell you that in a moment. Okay. Kavish, which operating system are you using? Linux or Windows? Windows. It seems like you are not running Docker. Docker for Windows. So just go there. You will find an icon. Make sure that you see this window first. If you see this window, everything will work. If you don't see this window, that means you are not starting with the Docker. That's the main reason why it is not working. It is open, then it has to work. Then restart your command prompt. It will work. Okay. Diksha, the problem here is sudo. You did not use the last command. Use a mod command. That's the reason use sudo docker image ls. Probably it will work for you. If it is a permission denial, use sudo. Otherwise, it won't work. That's the reason I gave you the last command. Sudo user mod -a capital G, your username docker. Unless you do it, it won't work. Yes, the Docker daemon is not running. That simply means restart the application. Make sure that you have installed that. It started successfully. You should see that icon here. If it says the desktop is running, then and only then it will work. For hardware-assisted virtualized execution protection, you will have to restart your machine, go to BIOS settings, and turn on the virtualization. Okay. For Linux and for Linux, if the service is not running, you will have to start the service. Sudo systemctl start docker d. That's it. Docker daemon. That's it. You are using Ubuntu, right, Shrishti? So start the server there. It seems like something. Just a sec. Seems something like this. Oops. Okay, so seems something like this. Go here and say sudo systemctl start docker. Docker or dockerd, both of them are okay. So use this command on Windows. Okay, docker, start docker, not dockerd, start docker. So do it in this way. It's not user add, it's user mod. It's user mod. Did I say user add? It's my bad then. It's user mod. Sorry, it's user mod, Tejas. The command is sudo user mod -a capital G docker and the user. Exactly. So that's how we are going to do it. Might have I missed it. So the command is like this: sudo user mod -small a capital G -a for append capital G for group docker and your current username. So current username for me is Amit K, for example. So that's how I'll do it. And after you do it, you'll have to restart the operating system. Otherwise, it won't work. Okay. Yes, restart the operating system. Otherwise, it won't work. True. Okay. Guys, if it is not working, leave it. Just see the things and you can do that later. Otherwise, we will waste our times. There are 255 people. So if I start fixing all the issues, I think the entire rest of the sessions will be kind of, we will spend fixing the problems and not looking at the contents. I hope you can understand. If it is not working right now, leave it, do that later. You have the entire day tomorrow. So probably later tonight or maybe tomorrow in entire day, spend some enough time, spend some quality time and get the things installed. Okay. You can Google and you can find out the solution there. When you see that it's not running, that means the Docker is either not started or you have the permissions issue. Go to Google and you will find it. Okay. So probably you can do it. Okay, so Anshul, this is how the Docker architecture, I'm sorry, this is how the Docker architecture is. In that Docker architecture, you see that this is the main part, this is the core part, or you can say this is the heart of your Docker. This is the Dockerd, which uses something called as a Docker, something called as a lib container. The lib container provides the namespaces cgroup and unionfs. This Dockerd provides the REST APIs. REST APIs will be consumed by any application, but we don't have to do that because Docker comes with a pre-defined or pre-built binary called as a Docker, and that Docker command is going to consume all the REST APIs and will do or will provide all the options for us to manage the containers, images, networking, volumes, and stuff like that. Okay, yes. We'll use the WhatsApp group for solving the issues later. Absolutely right. Exactly. Is UnionFS in-memory FS? No, it's a physical file system where the files will be stored in terms of different layers. Wait, and I will talk about that in a minute. Okay. So I think there are different objects. Maybe we'll just discuss them right now and we'll start doing the stuff practically, and then we'll understand what exactly that UnionFS and how does it look like. So Docker has got different the objects here. For example, images or image is an object, container is an object, network, volume, registry, service, all of them are the objects, and those objects are managed by Docker. For example, when you say image, it's a read-only template with the instructions for creating Docker containers. What do you mean by that? We'll explain that in a minute. Containers are the running instances of Docker image. Network interfaces for communicating multiple containers together is what the network is going to be provided with. The volumes are used for persisting the data outside the container. Even if the container is going down, you still will have the data persisted. Registry is where we can have all the Docker images stored, and service is used to run multiple services or microservices together. Towards the end of it, we'll show you in the orchestration part. Installation is what we already have seen. Now let us start doing something practically, understanding what exactly that UnionFS and what exactly do you mean by that image. So let us understand first what is an image. Image is an executable package that includes everything needed to run an application. This application source code, runtimes, library, environment variables, configuration files, and whatnot. Whatever you need, you will have to put that in a container. But to add that in the container, we have to first define the template. That template is called as an image. So it's like this. If you're coming from object-oriented programming, and if you know object needs to be created, but to create an object, we need a class. So class is the image and object is a container. As simple as that. It's a read-only template which has the instruction for running the containers. So if you want to start the container, this is an image we have to first write, and whatever is written inside that image, those instructions will be executed one by one when the container starts. It's like the container is an instantiation of an image. In order to run a container, the developer first need to package the application along with its dependency in the form of Docker image. So basically here we have to give, or we have to put the instructions in a Docker image, and that Docker image will be used later for creating a new container. It's highly portable and can be shared over network, stored and updated later. I'm talking about the image, not the containers. Container cannot be updated. Containers are always immutable. We'll see that in a moment. Docker provides a public and private registry which contains collection of pre-built images. That's a Docker Hub. We'll see that in a second. If the image you are looking for is not available publicly, you can create your own image by using Dockerfile. Tomorrow's entire day we are going to spend on creating our own image, optimizing it by using multi-stage build. We'll put them in the Docker registry, and the Docker Hub registry will download them, will create the containers, and everything will be done related to images tomorrow. I mean, not only tomorrow, today as well. One image can be based on one image can be based on multiple other images. This is what we are going to see later tomorrow when we create our own image. Now, enough about the theoretical part. I want to start with first that image and the stuff. We'll do it practically. Let us understand what and how we can do it, and then probably we'll see the images, how they are getting constructed, what is the image registry server and stuff like that. Okay, let's do this first and then we'll go for the actual one. So the Docker image, if you want to use it or if you want to download it, you will have to find it inside something called as Docker registry server. The Docker registry server is where you will find the pre-built images. For example, I want to run, let's say, Apache inside my container. How do I do that? Do I need to start from scratch? No, you don't have to. You go to this website, hub.docker.com, not this one, hub.docker.com, and there you will search for any image that you are looking for. For example, I want to run Python inside it. I want to run Mongo inside my container. I want to run MySQL inside my container. I want to run, let's say, Postgres inside my container, or maybe Angular for my inside a container, and whatnot. Whatever you need, you will find all the images inside the Docker Hub. If the image is not available, we are going to create our own image as well later. Okay, so this is called as the registry server. The registry server is going to have different images, different versions of those images you are going to find here. We'll see how to use that Docker Hub and how we can download the image and how we are going to use this for creating our container. Okay, let's do this practically now. Is containerd and runc are repackaging of libcontainer? Is libcontainer the old architecture? If I see the process hierarchy, I see the dockerd, containerd. Exactly, containerd and the dockerd, both of them are using library called as libcontainer. Libcontainer is not shown anywhere. It's a library which is using behind the scene. Okay, Amit, I think you got the answer. Kuldeep, can image created using a Docker run any other runtime environment? Wait, we'll talk about that. What is Nginx, Prabal? Nginx is the web server. We'll see that in a moment. Harshad, can we get a copy of PPT to download after you create it? So yes, of course. I'm going to share every single thing there. Not only that PPT, whatever I've drawn so far, I'll share this same copy which I'm using right now. Okay, don't worry. So this is the Docker Hub, and I want to start with the simplest image. Let's say I want to start with the Hello World image, and this is recommended. So when you install your Docker, you want to see whether everything has got successfully installed or not, and that's the reason why not this one. The Hello World image is given by Docker. Search for Hello World or simply Hello World, and this is the Hello World image which is given by Docker. Okay, you see that there are many Hello World images. This is the one which has been downloaded. This is official image given by Docker, has been downloaded more than 10 million times. So that's very famous, and that's the one which is going to tell you whether your application or whether your Docker has got properly installed or not. How do I do this? To do this, we are going to start using different image related commands. Okay, so I'm going to do a little bit slowly. If you already have installed them, install the Docker, then you can run those commands. If not, then just watch me doing it, and later you can do it on your own. The very first thing I want to see how many images I have got created, I have got downloaded here. I can do that with the command docker image ls. Docker image ls is going to give me the list of images I have downloaded on my machine. Seems like I have got Mongo and I have got Alpine for now. Now I want to download that image, the one which I saw there on the Docker Hub, named Hello World. How do I do that? To do this, we are going to use the command docker image pull and name of that file. name of that image. The name of that image is hello dash world. So this is the one, hello dash world. We are downloading that image, and see, the image is getting downloaded from Docker Hub. This is the default registry server where all the pre-built images are kept, and you can download them as and when you need them. So I needed that hello world. I downloaded that by using the image pull command, and I see that the hello world is now got downloaded. How do I see whether it is getting downloaded or not? I can use the mhls command, and then it tells me that yes, the hello world command is now got installed here. So Docker is not running on your machine. Excuse me, Nilaknath. Then so probably it's better you can see if the Docker got installed properly and if the Docker daemon is running, because without that you can't do anything. Or simply use the sudo and then try to do this. Those who are facing the security or permission related problem, say sudo docker image ls or sudo docker image pull and so on and so forth. Okay. Amit, it is not working without sudo command because you did not use the last command, usermod. Sudo usermod -a capital G docker your username. That is what is needed. Anyway, so coming back here, it seems like I have got the Docker image here, and the Docker image is now downloaded. Now let us understand what happens when I download the image, what gets downloaded behind the scene. To understand this, I can't show that on Mac or on my Windows here, because these are the desktop versions. These are not the real versions. These are just emulation of Linux, because you have to use Linux in order to run your containers, because the containers are based on the Linux kernel. So I'll show you what you mean by that. So probably what I'm going to do here is, let me reorder this so it will be easy for me to switch between the things. So when we talk about this, use this command, docker version. It will tell you what exactly is installed on your machine. You have got the client version installed, you have got the server version installed. When I'm running this command on Mac, it tells me on my client side, I'm using the Darwin. Darwin means it is made for Mac. If I do this command, if I run this command right inside Linux, it says that the client is Linux and the server is also Linux. Look at this one here. The client is for Mac. Absolutely yes. There is no second thought, because I'm on Mac. It has to be a Mac client. But look at the server here. The server here is telling me it is a Linux server, not the Mac server. So what is happening behind the scene? Whenever you are running the containers, these containers are going to use Linux behind the scene. We are on Mac. If we are on Mac right now, how can I run Linux on Mac? So behind the scene, it creates or it downloads a small Linux version, and then it runs the container on top of it. So behind the scene, when you are on Mac or on Windows, it's not the true containers. It's like virtualization, and on top of that, the containerization is it's getting run. And that's the reason why I said you cannot run few features on Mac or on Windows, because these are not the true containerization platforms. That's the reason why they named them as Docker Desktop. Desktop for Windows and Desktop for Mac. Both of them are not going to give you the true containerization. Check this out. If I use this command here, Docker version, it tells me the same thing here. Look at that. This is Windows, no doubt in that. I mean, the client has to be Windows, client has to be Mac, client has to be Linux, depending on the operating system. But what is important? The server is Linux for Mac, server is Linux for Linux, and server is Linux even for Windows. How is it possible? Understand this. This is possible because of this. So let me go back here, add a new page, and see how is it possible. I'll give you 3 different options here, or maybe we can directly do that right here. This is my, let's say, Windows or Mac machine. Okay, so probably there is a hardware I don't care about. The operating system is what I'm going to care about right now. So I will say this is the hardware. An operating system will have 3 options here. Watch this and understand this. Someone was asking that question last time. Can we run Linux containers on Mac or on Windows? I said yes. Why? This is the reason behind it. Okay, understand this reason here now. So probably this is, let's say, Mac OS, this is a Windows, and this is a Linux. So we have got three different operating systems here. Now let us understand what happens when we are having Mac, or when we are having, let's say, Linux, and when we are having something like a Windows here. So probably this is the difference between them, So understand the difference now. Okay, so when we are installing Docker, that is going to remain same. So Docker here is going to remain same. Docker here is going to remain same. And Docker here is also going to remain same. So what is the difference here? When we are using, let's say, containers later, so these containers will require the Linux server. So what happens here is, if you are on Mac, this container will require Linux. So behind the scene, the Docker will create a virtualized environment for Linux. This virtualized environment will be managed by managed by the Docker itself. You will not see that. This will be by default created for you when you install Docker on both on Mac as well as on Windows. So this is where the container will run. So this is C1, let's say this is C2, and these C1 and C2 containers, you see, they will run inside those Linux container, or inside that Linux virtualized environment. So what it looks for is the Linux kernel. So Docker creates the virtualized environment for Mac and for Windows. You know what? Because we are running the Linux here, we don't have to simulate it. And that's the reason this is the true containerization, C1 and C2. And you see, now they are going to share the operating system here. This is again Linux. This is the true Linux container. This is the true containerization. This is not the true containerization because it's kind of a virtualization. This is virtualization layer. This is virtualization layer. And on top of that, we are running the containers. So for Windows and for Mac, this is kind of a virtualized environment. And this virtualized environment will be kind of giving you the containerization for Windows and for Mac. And that's the reason why this is, this is not true containerization, This is true containerization. That's the benefit of using containers there. And that's the reason in production environment, we always will go for Linux and Linux. Yes, and that is the reason why we should not use, or why we should use Linux in the production, and why we should not use Mac or Windows on the production environment. So probably you can now understand it here. Yes, Praveen, what's the difference in the Docker, or maybe what's the difference between the Windows containers then? Look at this. This is, this is a Windows container now. Windows container is not available for Mac, and it's neither available for Linux as well. So probably I'm going to literally copy this one here and understand this. Isn't it possible for me to run Windows inside a container? These days it is possible. Earlier it wasn't. Microsoft recently has added the support for running Windows applications inside the container. So how does it work? It works like this. This is the Windows application, So this is a Windows container 1. This is a Windows container 2. Because the Windows container requires Windows and the Windows is available here, this is the true containerization. So Praveen, this is how the Windows containers will run on Windows. This will not work on Mac. This will not work on Linux because Windows virtualized environment is not available for Mac and Linux. See, this is the virtualized layer I'm talking about. It's available for Mac, it's available for Windows, and that's the reason you run all of these Linux containers on Windows, on Mac, and on Linux. But these Windows containers will require Windows kernel, and Windows kernel cannot be virtualized on Mac and on Linux. So you cannot run Windows containers on Mac kernel, I'm sorry, on Mac machine and on Linux machine. Praveen, I think you got your answer. Okay. So that is the difference between Linux container and Windows containers. By default, understand that. By default, every container we are going to create will be always Linux container. So this is Linux container, you know. If you need to run Windows applications, you are going to need the Windows container, and this is only supported on Windows, you know. How we run that Windows subsystem. That is what I said. This is how it is going to run it. This is how the Windows kernel will be used on only on Windows environment. So this is possible only on the Windows environment. This is not possible on Linux. This is not possible on Mac. It's only possible on Windows. Can we run Mac containers? No, you can't, because Apple has not enabled Mac to run inside the container. So you can run Linux by default. Windows, I mean, the Microsoft has recently added the support for Windows containers, but Mac, Apple has not added any kind of support for that. Okay. Harshit, is it to create a virtual environment? Yes. Harshit, the Linux environment, virtualize the environment and the base image we defined in the Docker file are the same or the different. We'll talk about that. Aditya, is there any performance or any other known issues while running on Mac on Windows? Of course, the performance will not be kind of what you are going to expect from them, because they are virtualized environment. You will get the best performance right here on the Linux, and that's the reason why we are using Linux in the first place in the production environment. Okay, so always all images should run on Linux naturally if they are Linux images, not on Mac or not on Windows. Friends, Windows containers means any Windows application written by using .NET and application. Absolutely right. This is a .NET application, Windows application. So whatever .NET applications you want to run on Windows, you can run them inside the containers on the Windows operating system. That's only available only for Windows. That's only available on the Windows operating system. Okay. Windows container cannot be shipped to the other machines. You can't. You can run only on the Windows here, because Windows, virtualized Windows is not available on Mac and on Linux. That's the reason only Windows can be done there. Mac is definitely OS X. Of course, Mac is definitely OS X. macOS is nothing but macOS X. Nowadays, it's not macOS X. X means 10. Now we are using macOS 11 version. So don't say macOS 10 or macOS X. Say macOS. That's it. Okay. Sachin, your question, can I use 3 containers with the different OSes in one hardware machine? No, you can't run Mac in the first place. You can't do that. You can't run Linux containers on, you cannot run Windows containers on Linux or Mac. You cannot run Mac containers at all. You can run Linux containers on Windows. You can run Windows containers on Windows. That can be done. Okay. Prince, does it mean for Windows container we do not need the Docker terminal on Windows operating system? Of course we need it, but just we are going to use the Docker, which is going to run the Docker container for for Windows and not for Linux. So I'll show you that later, an example of Windows version of container. Okay, right now see this, the Docker is having the server for Linux, Docker is having the server for Linux, even if you are on Mac or Windows, because that's a emulation of Linux. This is not the true containerization. This is virtualization, and on top of that there is a containerization. That's why we should not use it. Anyways, I'm going to go back here on on the Ubuntu system, and I'll show you. You already have got downloaded that image. I guess Hello World is already available here. So if I see Docker image ls Hello World is available, I want to see what happens with that image, what is there inside that image. We can use another command, Docker image inspect. Name of that image is hello-world. Sorry, hello-world. So when I say Docker inspect, Docker image inspect, this is the next command we are using. And if I pass the image name, it shows me every detail about that Docker image. It tells me what is an image ID, how we can identify that image uniquely, where it is coming from, what is the tag we are using. Tag is nothing but the metadata of it. What is the digest of it? We'll talk about the digest in a second. which container can be created, for example, which container has been used to create that image, so on and so forth. The container configuration which was used while creating that image earlier. This is the configuration of image. By default, there is no hostname configured, domain name configured, user has not configured. Which environment it is going to give me? Environment is set here. Which command it is going to execute when the container gets started, and what is the image? Image in a sense, what are the different options? What are the different contents inside that image? Most important thing that you should look for is something called as the layers collection, and this layers collection is telling me that there is a layer somewhere here. So what is the layer and what is the meaning of it? Let us understand this first, and that is what that will give you an idea about what exactly that union file system is. So this layered file system, or the layer which I just showed you, the layers collection which I just showed you inside that Linux here, is what given by that union fs. So Docker's layer file system is something which is given by the union file system, or union fs. So Docker images are made up of multiple layers. What is a layer? A layer is going to represent a kind of instruction to be executed inside your container. So Docker uses union file system for implementing the layered Docker images, and that's where the union file system is needed. Any update on the image adds a new layer. So whenever you are adding any command, it is going to add a new layer on the existing image. When an image is instantiated into a container, a top writable layer is created, which is deleted when the container is going to get deleted. A Docker uses the storage drivers to manage the contents of image layer and the writable layer. What do you mean by that? I'll show that in a second. Each storage driver handles the implementation differently, but all drivers use the stack images layer, copy on write or COW strategy. What do you mean by this? When the image gets created, it will have different layers. The most basic layer is called as generally the manifest. Manifest means it is the most basic layer. It is going to have all the operating system details, for example. On top of that, if you are doing something, let's say I want to copy a file from my application here, maybe I want to copy the source code of my application here. So it creates a new layer. Let's say copy source. This creates a new layer. Next, if you want to install something here in order to run your application, let's say this is a Java application again, and if I want to run this, I will have to install JVM. So install JVM is nothing but one more layer here. Again, on top of that, I want to run my application continuously, or when the container starts, I want to run that I want to run that class here. So run the application is going to be an image again. So all of these will be added inside one single unit, and we call it as an image. So this is an image, and images made up of different layers. So what do you see here? You see all of them are different layers. So this is my layer 1, this is my layer 2, this is my layer 3, and this is my layer 4. So it depends on that image, how many layers you want to add and how many layers you want to update it with. This is an image. When you create a container later out of this image, one writable layer will be added, because containers, the images cannot be modified when our images are used only for the templating or adding the instructions to create a container. So this is a kind of an image you can see here, and this is a kind of container here. I will call this as a container. So this entire representation is a container, and this entire representation is an image. So image is going to have all the layers, all the image layers plus the containers, something called as a writable layer. Writable layer, in a sense, whatever you do inside that container will be stored here. And once you delete the container, this layer will be deleted. So image will stay on your device, but the writable layer will be deleted. That's what I mentioned here. So whenever you are creating a container, your image will be used, and on top of that, one writable layer will be added, and that writable layer will be used for storing in a sense, will be used for adding all the things which you want to put inside your container. When you delete the container, the writable layer will be also deleted. Okay, so what or how do you do that then? To do this, you will have to have the support for layered file system, and that layered file system support has been added by the Union FS, and that's what I was showing you earlier, you know. So how do you do that? That's what we have to see right here. This is where we can see the list of layers. You see, this is the layer which is having inside that image. Where the images are getting downloaded, if you are on Linux, you can see that inside /var/lib/docker. So if you go to this directory, you will see all the contents of the Docker subsystem here. For this, we'll have to say sudo -i so that I can log in as a root, because after that you will not get the permission. So I'm going to go back again to /var/lib/docker, and right inside this, you will see different folders. Inside it, there is a folder called as image, where the images are downloaded, images are stored, you know. So inside this images, you see overlay 2. This is the driver which is used for storing all the images to here. So I'm going to go back to that overlay 2, and you see that it is having different folders. Along with that, there is something called as repositories.json. So probably when I use the command docker, what the hell here? So docker image ls, it shows that this particular image has been downloaded. How does it know that? It knows that because this information is updated inside this repository. So if I go back and say cat repository.json, you see, this is telling me that there is only one image right now available on my machine called as a hello world, which is having a tag called as hello world latest. That's what you see here. Hello world, the tag is the latest. This is the ID bf75 blah blah blah, bf75 blah blah blah. It matches here. This is the layer which is created, or this is the version it is created inside it, and blah blah blah. That is where it shows all the information of it. So it tells me that this is the image which is downloaded from the Docker Hub. No, you can't see that on Mac, you can't see that on Windows. Both of them are Docker managed, so you can't see them. That's the reason I'm using Ubuntu in this case when I want to show you all of these details. In Linux only you will see this, because in Linux it's true containerization. For Mac and for Windows, Harshit, both of them are simulation, so you cannot do anything there. Nilaknath, I'll put all the commands in a file and I'll share that file with you. Okay. Okay, so here we are, and if I go back to that overlay, if I go back to that image DB, this is where we can see the content, and this is where we can see SHA blah blah blah, and this is where you will see BF blah 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 blah. This is the actual information. If I just put this under cat, you see all the information here: architecture blah blah blah, config, and so on and so forth. This is the same information you just have received by using the command, something like a docker. You remember the command which we have used the last time to see the information about an image? Docker image inspect. Name of that image is hello world, and you see all this information. This information is written inside that file. So if I say cat b7 whatever it is, you see all the information is exactly written inside this. So this is how it is storing that. It is how it is telling me that the information is getting it's getting read from that directory /var/lib/docker. Anyway, so you see all the information here now. So probably if I go back to the layer DB, these are all the layers downloaded for different images. Right now, if I go for that SHA-256, I see that is the only one layer. Do you remember that? If I use the command again, docker image inspect hello world, and if I see how many layers are there, you see that there is only one layer, sorry, world. So if you see there is only one layer, the layer starts with 9C2 blah blah blah, if you see and if you compare these two numbers are exactly same. So basically this is the layer of your image. So if you go to that directory, you will see that this is where it is having the actual content. So that is the zip file it is storing here, and this zip file is where all the information is stored, which is going to run when you create a container out of it. So this is an image which is storing all the layers. Right now there is only one layer in that hello world, but nothing to be worried about. You see, if I go back and say Docker image ls on my Mac machine, I see that there is something like a Mongo. So if I go back and say Docker image inspect Mongo, I'll see all the commands. Oh my God, here there are multiple layers. You see, this is the one which is telling me the list of layers. There is another command. You can say Docker image history and name of that image Mongo. It tells me what all different things are there inside those layers. You know, it started with the default layer or maybe the default manifest file, which is almost like 63 MB. On top of that, it has executed this command and created one more layer. On top of that, it has executed this command and created one more layer, and so on and so forth. Today, just look at this information and try to understand what is there. Tomorrow, with the introduction of Docker file and by creating our own image, you will understand what exactly do you mean by creating a layer one top of another. Right now, it is just to see, like these are all the kind of different different layers created after, I mean, one after another. But how to create that, I'll show you tomorrow with the help of something called as a Docker file. That is pretty much interesting than this. This is where we can see the ready-made part. Tomorrow we are going to create our own part. We'll see that. Right now, I'm going to use that same command, Docker image inspect hello world, and just want to see whether we can get this quickly. And you see that this is the layer which we saw there as well, 927 blah blah blah. This is going to be constant. Now I'm going to use the same command history just to see how that how that layer is looking like, or what is there inside that layer. So hello dash world, and you see that there are only two layers. I mean, those two layers are kind of squeezed together into one. So can we do that? Yes, of course. I'll show you that later, how to squeeze multiple layers into one to optimize the file size. So first, it has copied that file of 13 kilobytes, and on top of that, it has executed /hello. This is the one which is going to get executed when you start the container out of it. We'll see how to create a container in a minute, but this is how you will get the information about image. So to get an information about image, we can use two commands, inspect command and the history command. Remember this. Inspect command will show every single thing, and history command will show different layers, when the layer got created, what is the content of that layer, I mean what that layer is going to do. This layer is going to create, or this layer is going to copy that file, and this layer is going to execute the hello command inside this image. Okay, again, Docker image ls will tell me how many images are copied or downloaded on my machine. Okay, now I think the image I can see here, I'm going to go back and say exit and come back to my original command prompt here. And right now, if I say Docker image ls, I see there is only one image we have downloaded. So is it possible for me to delete that image if I don't need that? Of course, yes. You can say Docker image rm, and you can use name of that image. There are two ways you can identify an image uniquely. The image name :tag. If you don't use the :tag, by default latest will be assumed, or you can use the image ID. So probably when I want to delete this, I can say that Docker image rm. I may say something like a hello world here because that's a name, or I can say bf756 blah blah blah. So here I'm going to say hello dash world and see if it is possible for me to delete that image. So you see, it has deleted those layers, if you can recall what I just said earlier, and then it has deleted that image. So Docker image ls will tell me there is no image left on my machine. Not a big deal. I can download it very quickly by using the pull command and say this is hello dash world. As simple as that. It will take a minute for me, not even a minute, few seconds for me, and then the image will get pulled from a Docker hub on my machine. Again, Docker image ls is what it shows me. The image has been downloaded again. I want to delete it again. How do I delete that? This time I'm going to use the rm command, but this time instead of using hello world, I'll use the ID. Now, when you are using the ID, you can use the entire ID like this. Sorry, you can use the entire ID like this, bf7 blah 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 blah, or maybe we can say Docker. Remember that it's going to give you a simple way to interact with images and containers later. So RM, and this time I'm going to use not the hello world, but the image ID bf7. So instead of using the entire one, I can say bf7, and if I say enter, it still can refer that image ID. So when you are talking about the IDs, we don't have to put the entire ID. We can just use only a couple of letters. It will automatically identify that image ID, and then probably you can deal with that image easily. Praveen, is it possible to get the Docker file of existing image file on Hub? Yes, of course. I mean, provided the developer has added that. Okay, not guaranteed, but most of the times you will find it. So if you go back here, maybe inside, let's say the tag, which one, the Linux tag, for example. If I create on that Linux, you see this is the Docker file which is created, which is used for creating that particular version. That's it. So probably these are the layers you saw earlier when I used that history command. If I go for Mongo, for example, because it's already installed on my machine. So if I go for Mongo, and if I use any of the versions, for example, I'm using the latest version, which is 4.0. So probably I'll use this one here. If I click on that, this is the Docker file used by these people to create the Docker image for Mongo. See, it's very big. So they have squeezed a few lines or few instructions into one by using ampersand. We'll see these techniques tomorrow, but today this is the way you should do it. So Praveen, this is the answer to your question. You were looking for finding the Docker file of existing images. This is how you can get them. Anshu, your question is it if someone asks for interview the layer in Docker, how to answer? Actually, I didn't get it clearly. Layer in Docker, layer in image is nothing but it represents one instruction that will be executed in the container. So Anshul, I know just looking at this, you won't be able to understand what exactly the layer is because we haven't created our own image. Tomorrow, when we start talking about the Docker file, I'll mention every single statement inside the Docker file will create a layer. So this will create a layer, 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 and so on and so forth. Okay, so Anshul, wait for tomorrow. You will be able to confidently answer that question. What is a layer and how to create the layers, how to optimize the layer creation. Nilaknath, your question. Sorry, Nilkant, your question. Sorry, it's my bad. Nilkant, your question. Docker using git command implicitly? No, not necessary. It's up to you whether you want to put it there or that. This is the kind of info. This is the kind of you can say the way you can see the information is getting publicly shared with you. It's not needed, but it's up to you whether you want to share them or not. Not everyone is going to share that. It's up to you whether to share the Docker files or not. Okay, these are open source. That's the reason they have shared it. Amit, you are still getting that error. So response for conflict, unable to remove the repository. Seems like you are creating a container out of it. First, delete the container and then try to delete an image or hold. I'll show you what you mean by that. So Deepak, a layer is an instruction. Yes, to be precise, instruction inside a Docker file will create a layer. And I'll show you that tomorrow when we create our own Docker file and we'll create our own image. Okay. Prince, how is a layer helpful in the Docker image? Of course, that is the most important part of the image. I'll mention this tomorrow. I can't answer every single question today because there are few things we have to do one by one or step by step. Today, we'll just look at how do you download the image, how to get the image, how to convert them into container. Tomorrow, we'll dive into image and then we'll start creating the custom image, and you will see how helpful that layered architecture in Docker or in container is. So how it is going to reuse the layers and how it is going to make your containers perform very well. We'll see that tomorrow. Sachin, does that mean after executing every command, a new image is created to complete Docker file? No, not new image will be created, new layer will be created. That's the reason I didn't want to talk about that Docker file today. But someone asked that question, that's the reason I mentioned it. Put all the questions on hold related to Docker file. Docker file, all the instructions, all the commands, we will talk about them tomorrow. Okay, we'll see all those questions answered tomorrow. Can we relate an image file from OS? Yes, we can, but it will be really painful to create it bare minimum image with an operating system. It's very difficult, but it can be done. Absolutely. Okay, so I think we were talking about the images, and hopefully we talked about how to download an image, how to inspect an image, how to see a history about an image, how to delete an image. That's it. Now, what is the meaning of image if we are not creating a container out of it? So now we'll start creating our first container. You see how to create the container here. Okay. Yes, I'll show you that concept later, Sachin. It's not needed for your exam, but if time permits, I'll show you. Tushar, does Docker create a writable layer from already existing layers that come with the image? No, it creates a separate layer for containers. I'll show you what you mean by that in a second. See this. I've downloaded that hello world image, but that image is not so useful till I create a container out of it. So how do I create a container? Check this out. To create the container, you can say Docker. Do it along with me if you already have got this installed. So you can say Docker container, and you can say create, and the name of that image. The name of that image is something like hello-world. So you can say the container has been created. It has got created the container. It has done nothing, but it has just got created that container. How do I see the list of containers? I can say Docker container ls. So Docker container ls is telling me Mongo is running from last 17 hours. What about the hello world container? I mean, where is it? It's not shown here because it's not running right now. Only the running containers will be shown by using container ls. You can say container ls minus a for all, and there you will see the hello world container. It just got created. It has not yet started its life cycle. It just got created here. So probably if I go back to my Ubuntu, I'll see there also the same thing. Oops. What the hell? What the hell? Finally. Okay, so here I am. I'm going to say Docker image ls. There is nothing right now. I'll have to pull that Docker image for hello world again. It will take a second or two. Okay, I'm sorry. Image what? Image pull. Okay, so let's get that here. Will take a second or two. And that is it. So again, I'm going to go back and say image ls. I see the hello world. I want to create a container out of it. To create a container, I'll say Docker container create hello world. That's it. Sorry. What the hell is that? Hello world. And you see a Docker container has been created. Again, Docker container ls. So Docker container ls tells me there is no container running. No big deal. I'll say container minus a. You see that it is running one container here. Okay, so this is how we are doing the job. You are using Linux subsystem inside Windows. All installation as suggested done. Just want to know, is that the one in which base operating system is Windows and there is a Linux container inside it? Yes, absolutely right. That's what you have done right now. So I got that hello world container created, but I've not started it yet. How do I start the created container? Not a big deal. We are going to say Docker container start and name of that container or ID of that container. If you do not specify any name while creating that container, by default, it is going to use any two random words and it will create the name out of it. You can use this gifted plop, whatever it is, or you can use the container ID as well. So probably I think this is really difficult to pronounce it. So I'm going to use that container ID and I'll say that Docker start the container with the ID 2F35 blah blah blah. I don't even have to write the entire ID. I can say 2F3. That's it. More than sufficient. And you see that this container will get started. Check this out. Earlier it was created. Now if I go back and say Docker container run, oh, where is it? Has it not started? Actually, it started and it already has gone. I mean, it got exited as well. My God, where is the output then? So we could not see the output because when we started that, the output was shown behind the scene. So how do I get the logs out of it then? How do I get the output from that container? No big deal. We can say Docker container log and ID again. It's 253. And you see, I'm sorry, sorry, it's not log, it's logs. 253, the ID of that container, and this is the output that it was supposed to print on console, but because we started it, we created it and we started it, that's the reason we missed that output. Not a big deal. We can see that hello from Docker, this message shows your installation appears to be working correctly, blah 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 and blah blah blah. That's it. See, what did we do? We downloaded one image, we created a container out of it, and we started that container. So whenever we are kind of using that create command, the container will get created. And whenever we are using the start command, the container will get started. I mean, is it the hard and fast requirement that you have to first create it and then start it? No, there is a simple command as well. See the command now. I'm going to say Docker container. First, let's clear the mess. I'm going to say Docker container ls minus a because this is not running. It will not be shown inside the ls one. Okay, we'll show you all these commands one more time, Mayur. Look at that. So I want to delete that container first. This is of no use because it already got exited, you know. So if it is not if it is not of any use, I'm going to literally exit. I mean, I'm going to literally delete this container. Delete means Docker container rm and the ID it's 2f3, whatever it is, and say enter. You see it got deleted. So if I say, I'm sorry, if I say Docker container ls minus a, you will see there is no container running or exited or stopped. Check this out. Again, I'm going to do the same exercise one more time. I will see Docker list of images. I see the hello world is there. If I go back and say container ls minus a, there is no container on this machine. I want to create the container and I want to start the container. And I want to do both of them together. To do this, I'm going to use the command Docker container run. Run means it is going to create the container and it is going to run the container immediately. Or it is going to start the container immediately. Check this out. Docker container run and name of your image. Name of your image is hello world. And see what has happened. It has not only created the container, it has executed the container and it has shown me the output of this on console. It's a combination of create and start executed together. And that's the reason most of the times when we start the container, we use run command instead of create and start. This is the better option when we are going to run that container. Again, if I go back and say container ls, you will see it's not getting listed here. ls minus a shows me the container got created, executed, and then it got exited as well. So that exited container, I don't want to keep it on my machine because it's of no use. If it is already exited, that means it has done its job. So probably I want to delete this. How do I delete that? Same, Docker container rm. The ID here is 64A57 blah blah blah. I can just say 64 more than sufficient, and it is going to delete that container for me. So container ls minus a, you see it is kind of deleting, it shows me that the container got deleted here. That's it. This is the way we can deal with the container. This is the preliminary or the basic, very, very, very basic information about the container and the image. We can use one container, we can use one image, and we can create multiple containers out of it. Okay, see this. Okay, so probably this is what I was looking for. This is the last time I'm showing you. Watch this. Container run hello world. This time I'll use one more command along with it. So this is going to give me the information about that container. So the container got created, it showed me the output and stuff like that. Fine. So now if I go and say container ls minus l, you see that, I'm sorry, ls minus a, you will see that this container got exited. I can see the information about it. I can see what are different things logged behind the scene, or we can see the information about it. So I can say docker container inspect. Inspect is the command we used for image as well. We can say docker container inspect and say a8 blah blah blah, and it shows all the information about the container. You remember inspect command we used for image, and it showed me the information about images. Now it is showing me information about the container. So container inspect a8, it tells me what is the state here. The state is exited, and that's why it says exited. When it got exited, it started here and it exited here. It lived for hardly a few microseconds and it got exited. So this is the way you should, you should get the information about the container here. You see, there are no argument passed. This is an image which is used to create that container B7F blah blah blah. That means it's the hello world container, hello world image, I guess. This is the one B775 blah blah blah. So this is the image which is used for creating that container, and so on and so forth. All the information is given for this particular container here. Okay, so this is the information about the container. If I want to see the information which is written inside that container, I'm going to say logs and IDs A8, and it shows all the things which are logged in a sense. Someone, for example, if you are in Java, then system.out.println, whatever you do there, it will show here as a log. If you are using JavaScript, then console.log. If you put there, then you will see that here. If you are using Python, then print inside the Python will print it on console. That will be shown here. Whatever is shown on console, this is where we will see you can do it here. If you want to disable the logs plugin, then you will have to, you don't write anything on console. It's as simple as that. This has to be done on the application development side. So if I'm a developer and if I don't want anything to be logged, I will simply not write console.log, print or printf in C, and maybe system.out.println in Java. Okay. Siley, your question, why it exited and how? I'll explain that tomorrow. Prabal, difference between image and container is the image is the template and container is a running template. Absolutely right. Container is a running instance of image. Image is where we are going to put the instructions 1, 2, 3, 4, 5. And if you want to execute those instructions, you will create a container and you will keep on executing those instructions. As simple as that. What is the purpose of that command hello? Actually speaking, hello is one of the applications which is added inside the container. I'll show you every single thing. Don't worry. When you create your own image, you will understand every single thing. Right now, it's just 20,000 feet overview of Docker, of the image and the container. Tomorrow, once you start building your own image, you will start understanding all of these things. Don't worry. Aniket, Amit, could you please explain what ability does creating container provides to an image? Does it provide environment to run what is in the image? Absolutely. Whatever you have given in the image, that instruction or those instructions will be executed one after another when you create the container. The actual application will run inside the container. Maybe that image is just, you can say, instead of instructions, not more than that. Maybe Aniket, if you're coming from object-oriented programming, Have you done any kind of class or object instantiation, sorry, the class instantiation to create an object? If you have done that, when you write a class, you just put the instructions there. But when you actually want to store something in the memory, you create an object out of the class. Class is an image. Object is a container of that image. That's how you can relate it. Okay. Amit, what are you saying? I want to disable the logs. Yes. Okay. No, you can't disable that logs from container, by the way. Amit, your question, reposting my question. Sorry if I missed it earlier, related to the architecture. Is container D run C are repackagement of lib container? Is the lib container old architecture? I think I answered that question, right? Container D is it's a daemon which is using lib container behind the scene. Lib container is where which it is providing all namespaces, C groups, and something like a union FS. That's a library it is using behind the scene. So Amit, already I've answered that question. If I missed it or if you missed it, I answered it one more time. Lib container is the library which is used by the Docker behind the scene. Docker D is the process. Docker D is the daemon. Okay. Prince, how can we run multiple containers of the same image? You can run this as many times as you want. See this. Run hello world, 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 run hello world. So if I executed this, let's say a couple of times, and if I look at Docker container container ls minus a, you will see that those many containers have got created because every run will create a new container for you. So this is where all of these containers are sharing only one single image. So this is the benefit of having that layered architecture. We'll see that tomorrow. Madhukar, Kibana like software internally use the log command. There are many different options. Not only Kibana, there are many different languages where we can also do the console logging will be shown right here. Okay. Praveen, single container can run multiple images. You see that? No, images will not run. Single container, in a sense, if you want to create a container, one container can be created by using only one image. One container cannot share images. Okay. Praveen, you should be able to use logging feature. Try to set the driver to none. Logging driver. You are talking about disabling the logging from the Docker point of view. Yes, that can be done. For that, you will have to modify the Docker configuration. If you are looking for only the driver, there are different versions of driver. You can put that in a log file. You can put that as a JSON. You can also set to none, and nothing will be logged out. Logged in a sense, nothing will be shown to the user. If you really want to do it, this is only used when you want to completely disable the logging. I think I didn't understand that question earlier. So I thought maybe you wanted to say how to stop that logging. Mainly when you are developing the applications, if you're not logging anything, nothing will be logged here. The logging will be done, but it will not be shown to the user. That's what it is going to do when we are using the logging driver is equals to none. Okay, so logging will be done by default, but you will not see that coming out of the Docker or coming out of the container. But if you really completely want to stop it, better you don't write anything in the log in the first place when you are developing an application. Praveen, we can disable the logs from container. No, it has to be disabled only at the time of only from the Docker configuration. That's how it is. Sachin, can we see the details of lib container? I guess we talked about that. There are three things which lib container is going to provide. 1, 2, 3. 1, namespace, 2, C group, and 3, union FS. Rajendra, from where it is getting these names? Which names? These names are by default given by Docker. If you're not satisfied, if you're not happy with them, not a big deal. When we are creating that container, you can say minus name and say my container, and next time onwards, it is going to use your container. You see, my container, like this. By default, it uses those two funny names and club them together with the underscore. Okay. Rohit, container should automatically add and run depends on the load of application. Yes, absolutely that. What have you shared here, Divakar? This is the container layer image. Absolutely. That's what I showed you here as well. You see, this image and this image is exactly matching. That's what we said, that container means it is nothing but the whole set. This is the writable layer, and this is the images layer 1, layer 2, layer 4, layer 4. So this is exactly what I showed you earlier. Absolutely, Divakar. Okay. Samir, if a container is not removed after its execution is completed, does it consume any resource? No, it's not going to consume any resource from the CPU or from the memory point of view, but it is going to consume unnecessarily the writing layer from the disk point of view. So there is no point of keeping those exited containers. So you can delete them directly. Okay. Okay, so I think that is writable layer is like the metadata of image. No, writable layer is a separate layer created only for that container. And when you delete those containers, all the writing layers will also get deleted. Okay. Okay, I think I want to delete all of these containers now. So I'm going to say Docker container RM. I can delete all of them one by one. 85, A5, 85, FF, F5, sorry, FF, FF, F5, then BC, then DC, then 91 and A8. So delete all of them. I'm sorry. That's okay. So probably if I say container ls now, there is no container. I can delete all of them one by one, or tomorrow I'll show you how to write a small script, and that script will delete all the images at one single, in one single command there. Praveen, can we start a scheduler to delete the container, those which are not used? It's up to you. You can write a cron job and that can be done easily. Okay. Before a certain time, yes, that is in your hands. If you are a Linux administrator and if you know how to run the cron job, you can write a simple cron job to see whichever containers are exited. You can delete all of them there. Okay. Definitely. Okay, so I think today we just got 30,000 feet overview. Now in tomorrow's session, we are going to continue further and we will talk about some advanced stuff. Like we'll continue with the Docker container. We'll see how the Docker containers, some more maybe advanced commands in the containers. And then we will start talking about, publishing the ports, getting the top containers, maybe the container information. Then we'll start with the Docker networking, and we'll see what type of networks possible. Many things. Tomorrow we'll talk about all of this stuff. Okay. So today we are kind of done with that basic information about the container and few information or few basic things regarding the Docker images. We are going to also create our image starting from tomorrow. So we'll see how it can be done. Okay. Yes, I'll share that file later today. For certification, do we have to go for any exam center? No, both of them, you can sit at home and you can give them from your comfort of your home. You don't have to do it. You don't have to go anywhere. Okay. Akshay, which virtualization application are you using for virtual machine? I'm using VMware for that. So this is VMware instance. This is VMware instance. Okay. Can we do all of these things using Kubernetes portal? Of course, Kubernetes portal, not getting you. What do you mean by that? I mean the command. Yes, you can, of course. Harshit, will there be any practice exam provided by you? Of course, yes. I will provide few questions later. Definitely, I'll have to, because that's a preparation exam means I'll have to provide you the questions there. Amit, can you please write those commands in a file? Of course, I'll put those commands. I already have done that. I'll share that later with you. It's there on my other machine. I showed you that. This is the machine which I started today. So it's there on my other machine. I'll do it there. I'll just share it from there. Okay. Okay. So I think, guys, we'll call it a day today and we'll continue tomorrow. Okay. No problem. So again, thank you very much for attending this session, and thank you very much for staying till late night. I really appreciate your efforts. I'll see you tomorrow exactly at 7:30 in the evening. Till then, bye-bye. Have a very good night. Enjoy your tomorrow's day. If time permits, then install the Docker, be ready with it, Google it out, whatever issues you are facing, and be ready with it. So tomorrow we all can do all of this stuff together. I'll put few commands later on your WhatsApp group today, or maybe tomorrow morning, so you can get all of these images downloaded before we start the session. So you will directly start creating the containers without wasting time to download those images. Okay, I'll see you tomorrow exactly at 7:30. Till then, good night, bye bye, see you.